fighting freak knuckles, and we're at Pumpkin Hill. You ready? I ain't gon' let it get to me, I'm just gon' creep down in Pumpkin Hill. I got to find my lost piece. I know that it's here, I can sense it in my feet. The great emerald's power allows me to feel. I can't see a thing, but it's around somewhere. I'm gonna hold my head, cause I have no fear. This probably seems crazy, a graveyard theory. Our ghosts try to approach me and got leery. Ask him a question and he vanished in a second. I'm walking through valleys, crying pumpkin in the alley. Didn't seem happy, but they sure tried to get me. Had to back him up with a fist metal crackle. I'm hearing someone saying, you a chicken, don't be scared. It had to be the wind, cause nobody wasn't there. I searched and I searched as I climbed up the wall. And then I started to fly, I went in deeper. Let it get to me, I'm just gon' creep down Pumpkin Hill, I got to find my lost piece. I know that it's here, I sense it in my feet. The great emerald's power allows me to feel. I can't see a thing, but it's around somewhere. I gotta hold my head, I have no fear. It probably seems crazy, a graveyard theory. A ghost try to approach me, he got leery. Just gon' creep down in Pumpkin Hill, I got to find my lost piece. I know that it's here, I can sense it in my feet. The great emerald's power allows me to feel. I can't see a thing, but it's around somewhere. I'm gonna hold my head, cause I have no fear. This probably seems crazy, a graveyard theory. I go man got leery. Asked him a question and he vanished in a second. I'm walking through valleys, crying pumpkins in the alley. Didn't seem happy, but they sure tried to get me. Had to back him up with a fist metal crackle. I'm hearing someone saying, you a chicken, don't be scared. It had to be the wind, cause nobody wasn't there. I searched and I searched as I climbed up the wall. And then I started to fly, I went in deeper. Let it get to me, I'm just gon' creep. Down Pumpkin Hill, I got to find my lost piece. I know that it's here, I sense it in my feet. The great emerald's power allows me to feel. I can't see a thing, but it's around somewhere. I gotta hold my head, I have no fear. It probably seems crazy, a graveyard theory. A ghost try to approach me, he got leery. Spooky up in here.
Me. Can you hear me now? Make sure that you can hear me on Twitch there. Yes, you can hear me. Fantastic. Thank you so much. All right. I hope you're all doing well. I hope you have all rested up a little bit. I hope you're feeling okay. Because it is the big day. We have the Project 1 launching today. We're going to be going over some logistics as far as Project 1 is concerned, and your immediate deliverables, which are going to be due Monday. And today we're going to also finish up with some kind of technical knowledge on raycasting. The idea that at any given time we really want the ability to shoot a beam through our physics space and see if we can hit something, right? See if anything is in front of us or below us or stuff like that. We are also going to finish up with the lecture on composition. So hopefully we'll be able to get through this early part pretty quickly, okay? A quick word of warning. I was very, very sick last night, so if I need to step out, I might have to do that. Also, if I sound a little bit weird, I apologize. It's likely due to that as well. Some announcements as we begin. We have a Roblox lecture being given tomorrow by Maxwell Perot, who is a former EECS494 and Wolverine Soft member. He now works at Roblox, which is one of the largest games in the world. If I recall, they recently, I don't know if they passed Minecraft or they came very close. I think they might have passed Minecraft in monthly active players. I think they're still below Fortnite though. But it's a fantastic story of a student getting super involved in the local community, working extremely hard, and then just nailing it. So definitely stop by IGDA Ann Arbor, which is our local branch of the IGDA. It's run by myself and my colleague Corbin Reeves, who's the game dev professor at EMU. It's going to be totally online, should be a good time. Okay? All right. If you go online, you can find a lot of really interesting and fairly high quality research and resources when it comes to game design analysis. Has anyone in the chat, thank you, I'll try and get well soon. Has anyone in the chat played Final Fantasy X? Final Fantasy X is a JRPG that has some very unique methods in which it does progression. Whereas you may be used to, you fight a lot, you get experience points, you level up, and that level up gets you a stat boost to all of your stats. Your attack goes up, your HP goes up, your defense goes up, your special attack goes up, kind of the Pokemon style. Whereas you might be used to that, when you level up in Final Fantasy X, you actually get essentially a token that you can spend to go around a game board. And depending on where you go on this game board, you actually get stat increases or you skip them. So you can kind of specialize. It's a very interesting system. Yes, a lot of you have played Final Fantasy X. That's very cool. I posted this really cool write-up and analysis of the sphere grid, which is the interesting progression system in which you travel around essentially a game board, spending your levels to get around this game board. Depending on how far you get and where you choose to go, you get different stat bonuses and you start to specialize and work out your character. What's interesting is that while this is what the sphere grid actually looks like when you view it in-game. This looks very complicated. So many different paths you can go to, right? Well, it's not actually the case. Because this, if you actually take and stretch out and organize in a line that these routes, in many cases, the route you take through the early part of the sphere grid is very kind of linear. This person talks about the power of presentation because it looks like you're traveling this maze. You feel the sense of adventure while you're just figuring out how to level up. And that's because it looks like that. Later on in the game, you do get some very powerful tokens, orbs they're called, I think. Or maybe they're called spheres, I can't remember. That allow you to essentially warp around this game board, and that really makes it go non-linear. So maybe this isn't entirely accurate, but at least in the early game, very, very linear. So anyway, if you have no idea what I'm talking about and don't care, here's the takeaway. There's a lot of really, really great analysis online, if only we can find it. Finding it and organizing it and kind of finding those ideas, kind of swishing them around in your head a little bit. Do you agree? Do you disagree? What does this mean for us? That is a really, really great way to kind of slowly build out your kind of game design expertise. You have a lot of different examples to work from in any given situation. Okay, let's keep going. A particularly clever deployment of augmented reality. As it turns out, like AR and VR is a big business these days, and while they may be struggling in the game space, when it comes to things like virtual exhibits, there is a lot of very cool stuff happening. Here's an exhibit that was created by, it looks like Pepsi's internal team. Yes, Pepsi, another team you wouldn't expect to have a game team. Indeed, they have it. So this is a bus stop with a screen. They overlay interesting things to make you think monsters grabbing someone, right? There's a monster underneath the city. He doesn't seem very fooled, or he'd be terrified. You've got a UFO. Uh-oh. I think there's a meteor. Oh, there's a balloon. That one's super cool. Incredible. Robot. So there are a lot of impactful experiences that you can make with VR and AR technologies. And the good news for you is that the stuff that you're learning now gives you a very, very fast start should you want to produce these kinds of things in the future. A lot of AR and VR houses use Unity for their strong VR and AR ecosystem. Alternatives would be something like Unreal Engine. And there are proprietary approaches too if you have a proprietary engine, but you don't hear a whole lot about those. Reduce, reuse, reduce, and recycle. So something you're going to discover, and maybe you'll discover this on Project 1 as well, is that it takes a lot of time to create high-quality, bug-free new components that are expressive and can do a lot of things, right? And a lot of your job on this Project 1 is going to be creating components that you can reuse. You don't want to create a new component for every enemy. You want to create 5 different components that you can mix and match on a game object in a prefab to create each enemy if possible. Now, that's not how it usually works out. Usually, each enemy is going to have at least like one custom component because most enemies have something truly unique about them that you can't really reuse on anything else. However, here's an example of a AAA studio, Nintendo, making good reuse of some earlier technology that they had. Here's the scenario. In Super Mario Galaxy, they have a sign system where you walk up to an object that is a sign, you press the A button, and whatever text, whatever bit of dialogue that sign is associated with will start running. Well, the designers needed the ability to make a door that you could interact with, but they didn't have any engineering time to actually get that done, okay? And so they said, wait a second, we already have a sign. We need to make this door look like it's talking to you in the same sense as a sign. So what can we do? Let's take a look.
For time. At the beginning of the Good Egg Galaxy, there's a house with a note attached to the door reading "Gone for a long time." Need to get in? Use the pipe on the other side. Instead of the door being readable, however, the developers took a shortcut by placing a signpost behind the door.
Boom, right there. And you're going to see more examples of this as our class goes on. We'll show you a few more of this where you're reusing stuff you already have as often as possible, right? consider that they could have created a new type of sign that explicitly is slapped on the door game object. However, every time you do this, you are essentially you'd be copy pasting a lot of code, probably. And every time you create something new, it's not free. You have to test it, you have to verify it. And as everything else in your game moves forward and gets maintenance and gets new features and gets more bug testing, unfortunately, that new technology would have to come along too. It starts to become a maintenance nightmare, particularly if you only use it for one door in the entire game. So anyway, okay, let's keep going. We're almost done through the announcements and fun stuff to begin. A not-so-rare instance of overscoping in the wild. This is maybe a little bit tangential, but one potential career path you can go to, and that we've had students go to, and what I do, is I run a startup that makes games for other people, for potentially small brands, YouTube brands. If you're a YouTuber and you decide that, hey, I create videos, but I also want to create interactive media, then you can hire people out there to make a game for you. And we've done that. Here's an example, a fun example of a client that contacted me and told me what kind of game they wanted. I asked them, hey, okay, your ideas seem a little vague. Can we try and narrow down what kind of game you would like us to create for you? And they told us, oh, it's a knock and run game. The genre would be fighting game because you will be able to do it all. Okay? And I felt really bad because this is clearly a client, as funny as it is, this is clearly a client who doesn't really know how difficult it is to make games and how scope can get you, okay? Scope is a concept that you'll be running up against very, very viscerally on Project 1 at the very end of it when you are creating a new mechanic and a new dungeon or a new region to put that mechanic through its paces. You need to keep scope down. You need to stay very focused. I want to do a limited number of things. I'm going to do them very well, and hopefully they kind of mix and match together pretty well. They're engaging and well-guided. So at Electronic Arts, we used to have a phrase, and maybe we still do, I'm not sure, but it's called the everything game. The everything game is a game with everything in it. And a lot of designs can start to resemble the everything game when scope goes crazy, right? So okay, we're gonna have a platforming game where you need to get from one place to the next. Well, wait a second. Instead of a platforming game, well, why don't we have an open world, right, to house that platforming game in? Okay, well that makes sense. But wait a second. How about we have NPC characters that have daily schedules that you can see them going to work, going home? And your team members start to think, wait, is that really necessary for this kind of game? Then you think, okay, we also need an RPG progression system. We need the ability to have you upgrade your jump as you jump more times because your leg muscles are getting stronger. And you know what? This would all be more fun if it was an MMORPG because then we can jump and platform with our friends, right? And the scope is just getting crazier and crazier, and pretty soon it has everything in it. It has realistic water physics. It has Minecraft-style course creation. This is not what you want to be. This should not be in your initial design doc. If you have a Fortnite-level success, you can start to build out features, but you don't want to go crazy right away. Okay, so someone asked about NPC. So a non-player character. So a character in a game that is not the player. Often they are set up with simple rules, like maybe when you talk to them, they're specified and configured to give you a certain piece of dialogue. And maybe if you're lucky, they have some pretty basic schedules that control where they'll go and what they'll do and stuff like that. MMO stands for Massively Multiplayer Online Game. So a game with a ton of people playing at once. Okay, so assignments that are due today. Your P1 team registration form is due. And we need this form in order to create your teams tonight. You already have your teams. And if you know who you're working with, you can just start going. You don't have to worry about it. Just start working on P1. Otherwise, You're going to need to wait until a little bit later this evening. After I'm done teaching, I'm going to go in, I'm going to create all your teams officially in Canvas and on Jira. Those of you who don't have teams, you'll get them, and you'll discover who they are via Canvas, okay? This usually takes a few hours. It's kind of monotonous. I wrote a script once, but I've lost it, sadly. So, okay, let's keep going. I haven't lost it. I've forgotten which GitHub account I have that has it. Anyway, we'll figure it out. So today's big event is the release of Project 1. Let's go ahead and let's go ahead and get into it. So Project 1 is probably the most challenging project in this entire course, and because it comes very early, there's very little time for it, and you need to learn a lot to get through its tasks, okay? The good news is that your deliverable that launches now and is due Monday, right? You've got, what, about 5 days to complete it. And you only have to do essentially one of a few different things. You have to create one enemy, you have to implement one weapon, and you don't have to implement the entire dungeon or area. Essentially, you're going to be creating the building blocks of the game, and then you fill it out for P1 Alpha, the next deliverable. Okay, when it comes to the schedule for this project, here are the dates that really matter. You've got today, the 27th. You've got the 1st of February, the 10th, right, about 9-10 days later, and then on the 15th, okay? And the 17th is kind of important too. That's when the very end of the project comes. You can think of this project in terms of 3 kind of tracks. You've got your engineering work, you've got your design work, and you have your kind of production work, okay? I'll go ahead and make my box disappear here. The very first thing that you need to start thinking about is P1 milestone. This is a deliverable that extends from the 27th, right, today, about 5 days to the 1st, okay? And it is your immediate concern leaving this lecture. Another thing that launches today but isn't due until the 10th is your P1 research assignment. Your P1 research assignment is an interesting assignment. We'll take a look at it in a sec. But essentially, it's an assignment that tasks you and your team member with playing similar games, playing other games from the NES library, so that you can kind of understand, okay, what makes The Legend of Zelda unique among games in its genres? What makes Metroid unique and impactful and enjoyable among its peer games from that era? It's very, very hard to design games unless you play games and unless you have some knowledge base to draw from, right? If you've ever heard the phrase, stand on the shoulders of giants, a phrase you've certainly heard if you've ever used Google Scholar before. The idea is you want to look at what has come, and you want to understand what has come before, and you want to be able to use that knowledge to draw from when you go and create new stuff, okay? Remixing things that have happened before, avoiding the follies of projects and games that have come before, and inventing some new follies of your own, I think. So, okay, let's keep going, though. Another tangent. You then have a P1 project management assignment that has released today, but it's not going to be due until the very end of the project. We'll talk about this. It's a very, very important assignment that often doesn't get the attention it deserves. However, this is the assignment that lets your instructors, your team members, understand essentially what you've done on this project, how much time have you invested, when did you invest this time, who's working on what, how long is anything expected to take, and what the progress on any given task is, okay? So it's very important for a number of reasons. Okay, after you're done with P1 milestone, so after next Monday, the 1st, your concern switches to a technical deliverable called P1 Alpha. This is a longer stretch of time. You'll have about 9 days instead of 5 to get this done. But P1 Alpha, chat, does anyone in chat know what alpha means as opposed to a beta? You've probably heard beta before, but what does alpha mean? Yeah. Yes. So debugged by devs, not quite. Alpha is developer testing phase, sort of. So alpha is typically referred to, at least in the game context, as feature complete. Okay? Feature complete. When your game is feature complete, when it is finished with the alpha phase, then you essentially have a project that has all the features that it's ever going to have. It has the levels it's going to have, it has the characters, it has the mechanics, it has the weapons, it has the content. The content is in the game, but it might be super buggy and it might not work, okay? So P1 Alpha is going to be a period in which you race to get everything done in your game that you can, and then from the 10th to the 15th, you'll have 5 more days to polish it all up, fix the issues that you ran into, and create a small new mechanic and a small new area that makes that mechanic important, that emphasizes that mechanic, that requires it to get through, okay? And I would actually like to show you some examples of what we mean by this, okay? So this is a really, really great example of a P1 Gold deliverable from Nigel Bale and Jennifer Daly. This is The Legend of Zelda, as you've never seen it, right? This is there's a motorbike weapon in this game, which is not in the original game. This is the new mechanic that the team decided to introduce. But you can't just create a new mechanic, right? Because new mechanic might not make any sense at all in existing stages and with the existing level design and progression. So the team created an entirely new dungeon that isn't super huge or anything, but that dungeon was designed specifically for this new mechanic. So you start in this room, you grab the motorcycle, and the only way to progress through this dungeon is to discover what the special abilities of this motorcycle is. For instance, the first thing you'll discover is that you can use it to jump gaps. You can jump larger gaps based on how far you're going, how fast you're going. So go ahead and drive around there, and then you discover, oh, okay, what happens if I drive to the lava here? Boop, right, and you jump across. The next room is all about teaching you that, wow, smaller enemies you can actually take down with the motorcycle. You then go into this left room. The old man gives you some advice. Don't stop, okay? Don't stop driving. So we're going to drive through this door. We're going to keep going. We're going to keep going. Oh my gosh. Okay, this section is meant to get you going fast, and then woo, right? This is just design perfection, right? The game gets you to go fast in a really exciting way, but the point of that is to show you the speed mechanic, the fact that you can actually jump more than one block of distance based on how fast you're going, and that your speed is a function of how long you've been driving without stopping, okay? And so the dungeon just progresses from there, introducing some small new ideas and emphasizing the bike mechanic, okay? Just a spectacular job by this team, okay? And it is fantastic. I encourage you to play it if you can find it online. They probably posted it to their online portfolios. Okay, and then I'll go ahead and make myself invisible here. And then at the very, very end of our assignment, when we finish on the 15th, we will have our P1 postmortem. This is an assignment that deals with essentially looking back and kind of gauging, okay, what went right on this project? What went wrong? What do we want to change? It is an essay assignment, and that might scare you. However, it's one of the easiest essay assignments that you'll ever run into. You don't have to worry about grammar. You don't have to worry about structure. You just answer the questions. You kind of dump your brain. You do some brainstorming, think about what you could do better on the next project. It's a very, very satisfying assignment, and it only takes about half an hour for most people, okay? Okay. So the last thing I'll show you is that just because this project has a lot of required tasks that are fairly specific, doesn't mean that you need to be perfectly authentic, okay? We will point out bugs and inauthenticities, but there are places where you can be a little bit creative. One of those is in what the old man says. So in this case, we've got a Caterpie showing up in the old man room. Anyway, if you're ever confused about where you have creative freedom, you can always reach out to us. And the assignment spec should help you out in this regard a bit as well. Okay? I want to give you a little bit of a better feel for how these projects tend to look. I want to show you a couple of high-quality, finished P1 golds, okay? And I'll show you a Zelda, and then I'll show you a Metroid as well. So let's go ahead and take a look at our Zelda example here. Yeah, I think they released that motorbike game before the Breath of the Wild DLC came out. Okay. Okay, so it sounds like Zelda. It moves like Zelda. It has the unique kind of subgrid movement system where you always line up perfectly with something. That's an important task that you'll need to figure out how to implement. We have the magic projectile that you get to shoot when you have full health. Notice it comes out at the end of the swing and not the beginning, creating a little bit of a delay. We can roll around. We got a fast transition there. We've got these key spats that have a resting state. They speed up, they fly around randomly, they bounce against walls. And if we take them all down, we get a key. Chances are this team is using a coroutine similar to what we used in a lecture on Monday. We can use keys. You can see the UI updates to show us our key count over there to go through doors. We got Stalfos. When you whack Stalfos, they get this cool damage effect. When we get hit, we get this great knockback effect. This is a really, really authentic and very, very impressive result here. Now, I think... Here we go. Right? And this is what we talked about. You can... Yeah, I encourage you to play this game if you can find it online. It's very, very fun. But you've already seen this, though. So let's go ahead and show you a Metroid P1 Gold in case you're working on Metroid. Oh, you can't hear me? My ears, your volume's too loud for us. You can reduce game volume. Ah, yes. So let's go ahead and do that. These older Unity builds take a long time to start up, I've noticed. I'm not entirely sure why. It shouldn't be an issue with your games, though. Okay, let's go ahead and where's the... Oh, it's over here. Okay. The mixer. Let's make sure this is pretty quiet. Use arrow keys to increase or decrease resolution. We'll make it a bit bigger for you. Press space for the Nintendo level. We'll do that first. Okay. Uh-oh, did we freeze? What happened? Oh, here we are. Okay, so what are the controls here? Here we are. So we've got our zoomers. These enemies are really interesting, and it's one of your first big challenges if you're going to be working on Metroid, is to how to program them to go around and perform this AI and stick to surfaces. Raycasting, which we'll talk about in just a sec, is going to be a really, really big part of that. We've got all of our power-ups here. We got the Morph Ball. We even have the freezing for when you collect a new item. A very nice touch. We can use the Morph Ball to get out here. I'd like to point out an incredible piece of game design that the original Metroid team did. In this room, you get the Morph Ball. Now, there are no instructions at all as to how to use the Morph Ball or what its purpose is. However, the game is designed so that you are trapped in this room. You cannot leave this room. You can almost leave it, but you can't quite leave it. You're trapped in this little area until you randomly discover what the Morph Ball does. It's very likely you will discover what the Morph Ball does because it just takes one press of down to make yourself tiny, which people will then use to escape. This teaches them about the Morph Ball, how to use it, and why you want to use it. We've got other enemies. I believe this is called the Scree here. We've got door transitions implemented in a very authentic way. Well, sort of. That's a little bit of an issue. You can't tell when the door is open or not. Its aesthetics betray its current state. But we got power-ups. We can get some health back here. Something I want all of you to notice. One of your first tasks will be to implement a standing jump in Metroid versus a running jump. Okay? A standing jump looks like this, and it actually works differently than a running jump, which looks like this, okay? When you do a standing jump, the controls work differently than when you do a running jump. And discovering what the difference is something that you're going to need to do, okay? So you'll want to find some way to play the game. I will note, for academic purposes, there are a very easy way to play all of these games if you do a little bit of Googling, okay? That's all I'll say on the topic. However, I do encourage you to find a way to play some of these games. I don't think the CBGA is open. That's what we would normally use. But you can also watch video and do other things as well. Let me go ahead and show you a P1 gold level of Metroid, and then we'll move on, okay? So we're going to press right shift to access the original level that this team created. It has a very different feel. It has a new type of enemy. This kind of zoomer variant, I believe, is a bit faster and a little bit hardier. So we're going to go through here. Oh no! All right. I hope I will make it. Okay, so we can use the morph ball. See how? Look how this level design is trying to encourage you to use the morph ball. It's just great. So we can go through here pretty easily. Whoa! There's a bit of a bug. Hey! Can we get you out of here? Uh-oh. I could use an F in the chat. Spare a thought for our poor bounty hunter Samus. I'm gonna try and play through this. The game actually implements a God mode, an invincibility mode, for the purposes of helping us grade the games easier. I do want to show you though how this level is just expertly designed. The level starts you off and forces you to deal with these challenges where you really wish you had the morph ball, and then you really wish you had a better morph ball, because you're trying to get through these gaps, and there are all these zoomers here that are gonna give you a hard time. Okay, so we need to wait for that zoomer to come through here, back out. Okay, it goes up top, we go below really quickly, we jump out, escape, good. Okay, so now we need to wait for these zoomers to get past here, we don't want to glitch them. Okay, we're gonna go through here. Okay. This level, if you haven't noticed, is all about the morph ball and kind of exploring what the morph ball can do and what it can't do. The game then finally gives you an upgraded morph ball. Here it is. Fireball collected, press S while rolling to charge. Okay. Uh-oh. We went into the cutscene twice. I hope we... Okay. Oh no, I hope I don't die here. Okay, good. So we can now use this mechanic. I'm gonna turn on invisibility mode. I hope I just did that. Okay. We can now use the morph ball to break through blocks, and we can also attack enemies and dive out of the way. You can see how this level design is just fantastic. It's designed to make you desire an upgraded morph ball, and then when you get one, it makes really great use of it. Oh, rest in peace, anyway. Okay, you get the idea, though. Alright, let's keep going. Does the cutscene use coroutines? It almost certainly does. Right? You can imagine a fairly easy way to design this kind of cutscene system with a coroutine. You touch an object, which has a special, collectible component on it. That collectible component detects that the player has touched it, and it launches a coroutine. That coroutine turns off the player controls, launches some music, and then does yield return new. Wait for seconds, like 3 or 4. Okay, by that point, the music is done, so re-enable player controls. Boom, we good to go. All right, so let's get back into it. Some really great examples. We'll show you a couple more interesting ones when we get to the actual P1 Gold. But let's go ahead and move on. One of the really interesting things about this project is that it's essentially the only project in the course where we prescribe to you certain tasks with certain deadlines, and their priority, okay? On Project 2 and Project 3, you will be creating your own tasks, okay, and deciding which ones take priority. However, for this Project 1, you actually have a tutorial assignment that can get you through most of the things you need to do for Monday. So let's go ahead and take a look at the Zelda tutorial. And there's another one actually for Metroid. Both of these are hosted on GitHub. Actually, you can find it right here, okay? Actually, let's go ahead and just talk about these task lists first. So these spreadsheets are what you're going to be caring about for the first part of this project. And essentially, it tells you all the things that you need to do. This spreadsheet has a few items, and it for every task that you need to do, it gives you the name, it gives you the description of the things you need to accomplish within that task, and it usually gives you a hint as well that should help you complete the task much, much faster. The important thing for you to notice right now, though, is that there's actually another column over to the right that's called milestone. This milestone column tells you when the task needs to be done. Does it need to be done for P1 milestone? Does it need to be done for P1 alpha? Okay. The ones in red need to be done by Monday for P1 milestone. The ones in white need to be done for P1 alpha or potentially P1 gold. Okay, there's a P1 gold task right there. These tasks also come with their own kind of time estimate. So this is all data that you will be plugging into your Jira project, okay? These spreadsheets tell you what all of your tasks are, give you what their priority is, which indicates how much points you'll lose if you don't do it. And yeah, it's somewhat straightforward. These tasks have tutorials associated with them. It's one of the first tasks that you'll see and something that you'll need to do by Monday. But essentially, you follow the tutorial, you go through each section. These sections essentially explain how to use some special technology in the course. Let me give you an example. As you go through this tutorial, what you'll notice is that a 494 menu will show up in Unity itself, right? I mean, we got some pretty powerful connections in this course. We call up Unity, say, hey, team, we really need a new menu in this software for our course. Can we get one? No, that's not quite how it happened. However, going through this tutorial will give you some new technology that essentially allows you to automatically generate this entire dungeon or the entire region without you having to drag and drop every single tile into this world. When I took the course, we had to do that. It takes forever. There are a ton of tiles in this world. We wrote some software that'll just generate it for you. So then you can worry about what do I put into this world, and not so much as how do I recreate this, okay? Anyway, you'll go through tutorials like this. It will take you through some of the basics, how to set things up, how to get your character moving around, how to get your map visualizing in the scene, how to create certain things that you can't walk through, for instance, and stuff like that. Okay. Let's keep going here. So you've got your task list. A bunch of those need to be due by Monday, but not too many. Something I want to show you is actually Jira. So where's the Jira? Here's the Jira mini demo. So tonight you are going to find that by midnight or so, you will have a new project that you can see on your Jira dashboard. We'll create it for you, don't worry. Once you add your teammates to it, you will see that you have something sort of that looks like this, right? You have this weird board, it's called, and all these options on the side. You got a backlog, you've got a release, you got a report section, and what you're going to do is you're going to go in and you're going to create a bunch of tasks. Don't worry, you don't have to follow this. The assignment specs walk you through how to do all of this and prompt you to do so. If you look at the P1 project management assignment. But essentially, you're going to go in, you're going to start creating different tasks. You're going to create issues. Okay, let's create an issue. Let's create a task. And, I don't know, we'll open the dialog so we got some more things to specify. Okay, what's my first task? Okay, my first task is play original game. So I'm going to go ahead and copy this in here. And what is our time estimate? Well, the time estimate is 1 hour. Okay, there we go. 1 hour, and there's 1 hour remaining from that since we haven't done anything yet. What's the description here? Well, let's go ahead and grab our hints and our well, let's grab both of them, actually. Can we paste these in? That looks pretty good. And what's our priority? Okay, the priority is high, so this is definitely something we want to get done, if possible, by Monday. Okay, now, what else do we got here? What else do we got? Okay, I think that's it. And who's going to be working on this? Let's say I'm going to be working on this, or I could assign this to my teammate. Okay? Well, I've got this task now, and we'd potentially create a bunch more for P1 milestone. When we have enough tasks, we'll click on Create Sprint. Okay? We'll create the sprint, and let me see here. Oh, there it is. So the sprint is not started, but I believe we can customize it here, although we might have to save that for you a little bit later. What you'd essentially do is you would drag in your stuff here, you drag in a task, and I don't think I can start a sprint because I already have one going on, but you click Start Sprint, you specify the timing, so what time does the sprint start, what time does it end. In this case, you would choose today. It starts today and it ends on Monday because that is the P1 milestone deliverable. So you create a sprint for that deliverable, and then you would go to your active sprints, and you would see that you have a ton of these tasks that are over in this to-do column. Okay? Now, these tasks, this is referred to as a Kanban board. And it's a very, very simple structure. You have a to-do column, you have a doing, and a done column. You can click on these tasks to learn more about them. And you can also log work on them. When you start to work on a task, you'll drag it into in progress. This informs all of your team members that you are working on a task. It's getting updated, and you'll start to log work. You do an hour of work. Let's say this should take 15 minutes, but you do an hour of work. Okay, you need to log it. So I spent 1 hour on this task. What did I do? Well, I played through and discovered first dungeon, but I didn't play through it yet, okay? And I've logged that task, okay? So now that task actually has time against it, and you can continue working. When you're done, you go ahead and place it there, all right? So if you wonder what is the point of all of this, well, you need to keep track of what you need to accomplish, right? If you are 1 day out from the deadline and you have a ton of these tasks still in the to-do column, you're in trouble, okay? And you're going to want to prioritize and decide which of these tasks you're not going to do at all. You also want to know, okay, what is my teammate working on? Because what they're working on might have a chance of blocking or impeding the stuff that I'm working on, okay? You also want to make sure that one person, more than one person isn't working on the task at the same time, okay? You don't want to clobber or trample on each other's work. So this can help you do that as well. Anyway, there are more advantages to this system, particularly when it comes to looking at reports, okay? But the P1 project management spec will take you through that, and we're running a little bit short of time here, I think. So, do we have any questions? The answer is yes. If you want a team member, if you have a task that's really tough and you want both team members to be working on that one task, essentially what you do is you'd say, okay, we're going to choose one team member that's going to own this task. It's going to be assigned to them. But however, we're going to schedule a meeting so that we work through it together, okay? We're going to note that we're both working on this task together, like put it in the description or activity or something, or in the work log. And then when it comes time for the instructors to look at what everyone's done, we'll see that note and it won't be counted against anyone, okay? So you can work on one task at the same time with both partners. And I do recommend this if a task is really challenging and tough, or you need help with it. However, Jira doesn't let you do that very easily, and so just assign it to one person, and then if you have a second task that you both work on, assign it to the other person. Okay. All right. Okay, let's keep going. Okay, I want to I want to make version control as easy on you as possible in this first project because when it comes to version control, Unity and Git do not mix very well. It is something that you'll need to use for Project 3 because Unity Collaborate only supports 3 people unless you want to start doling out some cash. So we'll get to and talk about using Git with Unity. However, on this first project, I really recommend setting up Unity Collaborate. Unity Collaborate is a built-in version control system that will track what things that you've changed in your Unity project and via this kind of button up in the top right corner of your screen. And if you click on it, it will actually tell you what you've changed. It will allow you to send those changes to your teammate or pull the changes from your teammate if they've made changes, okay? It is pretty good at merging scene files. So if you're both working on within one scene, which is kind of risky if you're using Git, usually it can merge your changes and make it work like that. It's not going to be a huge issue. However, we'll have to have better techniques when it comes to using Git on P3. You offer Git commits essentially when you go ahead and publish, and it's very nice to use. The only thing that's a little bit tricky is the initial setup, which this can walk you through, okay? So please go to this agenda, this lecture sheet. It looks like a lot of you are already there. And please follow this to get it set up with your teammate, okay? Okay, I want to introduce a topic to you called raycasting. It is a very, very important topic that can help you out a lot, particularly if you are a Metroid team. You're going to need it for Monday. However, if you're a Zelda team, then it's very, very important for you as well, okay? It'll be more important later on Project 1 and definitely in Project 2 and 3. Raycasting is the idea that we really wish we could figure out if something is below us or above us or to the right of us or how far to the right of us. Think of it this way. If you ever play a first-person shooter game, when the player goes to shoot, what many games will do is a raycast. They will essentially, in that one frame, they'll shoot a beam out from the tip of the gun barrel, and they'll see, okay, what does this hit? Okay, what does this beam heading out from the gun barrel hit? Does it hit a rock? Does it hit a player? Does it hit something else? And then, if it does hit a player, it will register damage if the player chooses to pull the trigger on that frame of the game. That is a raycast. You are casting a ray through 3D space to see what you hit. This can be used for shooting. This can be used for platforming, right? Many of you on Tutorial 1, in order to implement your jumping code, you used collision detection. However, it's like the on collision enter, on trigger enter. However, as many of you saw, this resulted in bugs. It was not a perfect solution because if you jumped against a wall, that detected a collision and allowed you to jump again. You became Spider-Man, jumping up the wall, right? Another issue would have showed up if you had any low ceilings, because you can jump, hit your head on that ceiling, that causes on collision enter to execute, which gives you another jump, right? So you can keep basically climbing along the top of the ceiling, okay? One better way to implement this would be to say, okay, I don't care if I collide with something, I care if something is beneath me, okay? I raycast downward every frame, and if I hit something, then I know that I'm right over ground and I should be able to jump. That would solve your wall climbing issue, because you might be bumping against a wall, but unless the raycast going down from your game object hits that wall, and it won't, then you're not going to get an extra jump, okay? Here's another example of when raycasts can be useful, tracking NPC characters and what they can see, okay? So in this game, I've created a little prototype. It's called Secret Snail. It is a stealth game involving a snail that is trying to get past these guards. These are the guards. They are looking, they're watching for us, and here is our secret snail infiltrator. Okay, this game uses a very simple means of deciding whether the NPC can see you or not. At any given moment, this game is ray casting out of the front of the NPC, where its eyes are looking. If we break that line of sight, as in if the ray cast that goes from the player's face outward hits a player, the guard will start to give chase, okay? Otherwise, they won't. They'll give chase until we break that line of sight and escape the ray cast. So let's go ahead and see what this looks like. You can actually play the game if you wish to, and I encourage you to play it and mess around with it. You can click on this link right here to play it online. I'm playing it in the editor because I'm going to show you some code in a second, okay? Let's make this a little bit bigger. Okay, there we go. Okay, so I'm a snail. You can see my snail trail right there, and I'm kind of rolling around. Okay, we got our first enemy here. If I go around them, there's no big deal, right? Can't see me. Now, if I want to know how close I can get, I can toggle the raycast lines. I click this button, and now it's showing me how far these raycasts actually go out. So I'm going to go ahead and run in front of this guard. Okay, it's now looking at me. It's looking at me. It's looking at me. If I can escape this raycast, it'll stop. Bingo. There we go. And it won't start chasing me again until the raycast beam is intercepted. Boom. Okay, it sees us. It's following. Okay, we're going to trick these guards right here into running themselves off the cliff. We're going to make them follow us and whee, right? It's kind of a neat little use of the game mechanic, isn't it? Okay. Cool. Okay, I'd like to show you briefly what the code for a raycast looks like. Okay? It's pretty cool and it's not too hard to use. Actually, chat, don't look it up, chat. Don't look it up. You know what a raycast does. It shoots a beam of light, well, not beam of light, but it shoots a beam through 3D space to see if it hits something. I'm going to ask you what you think the API for a raycast would look like. If an API is designed really smartly, then it should be intuitive, right? It should make sense. It only asks for things that are obvious. So chat, imagine the function call, physics.raycast. What do you think it takes? What do you think it wants from you to use it? So an API, an application programming interface, this is essentially your function signature. So there's some technology out there in the form of a function or a library or a DLL, whatever. But this library needs information from you to do work. For instance, if you have an API, a math library, that gives you the power of addition or multiplication or some power, right? A power operation, then that addition function might want two numbers, A and B, right? That would be the API. The API for addition would be give your first operand, give your second operand, and that would be your API. Okay, so the API, chat has the API in here for raycasting. Okay, a vector 3 and a length. Sort of. So you're almost there. You're missing something, Juicebox. You're very close. That vector 3 probably represents the direction you want to shoot in, right? The direction of shooting the API. And the length means, okay, how long do you want that ray to go? But you're missing one more thing. Object position, ray distance, length, and angle. Boom. Umich Viru has it. Let's go ahead and look at the code here. Whenever you want to understand how something works in Unity, first you find the interesting game object. So we found our game object, it's the player right here, and then you look at their components. Remember, a game object can't do anything interesting without components on it. So what kind of interesting components do we have on here? Well, okay, we got the arrow key movement, and if we turn this off, we can't move. So there isn't actually that much interesting stuff on the player game object. And this is actually a really good thing, because it's super easy to understand. Right? It has arrow key movement. It has a rigid body so it can move, and it has a sphere collider so other things can bump into it. Right? Simple. Easy. Good. Okay, let's look at the enemies. So if we look at our enemy prefab, every single enemy is going to have this amount of components. Okay, we got a sphere collider, that's pretty expected. We got a mesh renderer. We can turn it off there to make it disappear. What else? We got a chase script. What does that do? This chase component takes two things. The API for this component is a target transform. This must be the thing that it wants to chase, and a velocity float. So this is the number that determines how quickly the guard can chase us. Okay, that's kind of interesting, but more interesting is going to be probably the enemy controller. Let's go ahead and look. Let's go ahead and look in this. I'll have to bring Visual Studio down here to my bottom monitor. And hopefully we'll find some code that relates to raycasting, okay? We'll see if we can find it. Okay, so every single frame of the game, we have a function called debug visuals, okay? And if debug line render is equal to null, then we go ahead and grab a line render. This is essentially drawing those pink lines that show us where the raycasting is happening. So this isn't super interesting to us. It's just debug information, so we're going to ignore it, okay? Let's go downward. Fixed update. Okay, remember, this is similar to the update function that it runs repeatedly while you play your game. However, fixed update is usually reserved for physics-related stuff. And a raycast is a cast through physics space, so this is the place you're probably going to find this code. Okay? Okay, so first thing we have is a raycast hit variable. Okay? Our comment here tells us this is a structure that's going to be filled with data we can use after we run our raycast. Here is our actual raycast function call. We found it. Okay, and here's the API. If we look closer at it, we've got a physics.raycast function. It returns a Boolean. Now that Boolean, you can probably guess, is did we hit something or not? So if we hit something, then we return true, which means we can use this function in a return statement. So if we hit something, then do some stuff related to that something, right? Okay, what else about the API? Well, raycast takes a position, okay, a vector 3 representing the position we want to raycast from. It takes a vector 3 that says, okay, where do we want to shoot that raycast? What's the direction? And then we've got this really interesting little parameter here, out hit. Okay, this might confuse you, but essentially this is a way of sending a data structure into this function, letting the function fill it up with good information, and then getting it out. That's what the out means, okay? This hit variable is null when we create it, but when we send it into the function, this raycast function will fill it with good stuff, okay? It's a little bit awkward. It's something you might not have seen before, but essentially it's a way of getting multiple return values in C#. You get a Boolean out when you use this function, but you also get information about the nature of the raycast by getting it out through this variable. We then have a final value. This is the distance. Okay, this is the distance the raycast will shoot. It's only 5, so the guards can't see that far, which is something you noticed when we played. The rest of the logic is if the thing that we hit with this raycast, if it's Collider's game object, if that game object has a tag that says player, so in other words, this is a long way of saying if we hit the player with our raycast, then we want to begin chasing player. Okay, begin chasing target. The begin chasing target function requires a transform so that we know what object we want to chase. The object we want to chase is the player's collider, the player's transform. And let's go ahead and go to that function real quick. We can find it down here. Boop, right there. There we go. Okay, if our chasing component is equal to null, then we need to add a chasing component onto this game object, and then we need to tell that chasing component what it should be chasing. So its target is equal to the target that got sent into this function. In other words, when we send the player into this function, we're going to make sure we have a chase component on our guard game object, and if not, we're going to add it. And then we're going to tell that chase component that, hey, we want to start chasing the player, okay? There you go. It's relatively simple. And this is a good example of one component talking to another component. The enemy controller kind of runs the AI for detecting whether a player has been seen. And then once the player has been seen, it talks to the chase component, which is another component on the guard that has code relating to following something. And it tells it, hey, you should be following this. There you go. They work together. Without one of these components, the other wouldn't be able to do work very well. Okay. All right, so that's kind of how a raycast works. Now think about it. You're going to need to implement the zoomer, okay? those of you doing Metroid will need to implement the zoomer enemy, which is the enemy that kind of goes around this wall. Now, raycasting is by far the easiest way to implement this, okay? However, you'll need to be a little bit careful with how you raycast. And what does it mean when a certain raycast hits and another one doesn't, okay? I'll give you a little hint. When you implement the zoomer, Metroid teams, you're going to need to have multiple raycasts happening per frame because you want to know what's in front of the zoomer, but you also want to know if something is below the zoomer. That will inform you as to whether you need to turn clockwise or counterclockwise to go around walls. Okay? All right. Cool. Let's keep going. It's actually about time for our break. Okay? When we come back, we're going to go ahead and introduce a small tiny things, and then we're going to jump into that fun lecture on composition. Okay? In fact, we're going to jump straight into it, I think, right away, because I really want to get to that today. So the other stuff can wait. I'm going to see you in 5 minutes. All right, we'll throw some music on and we'll get back to it. Okay, what's a good? This is a classic song that maybe you've heard before, but this is actually a pinball song. Still game related, so we're still going to listen to it. Let's go ahead and do it. This song's so cheesy.
I am the Black Knight.
This would be at home in Pinball Pete's. Okay, go ahead and ask any questions you got, chat. What do people use channel points for? And can it be customized how you get them?
You got the power. You got the might.
No way.
Get ready for battle.
Give me your money.
Beat the Black Knight.
Cool. This is Black Knight 2000 Pinball. This song goes off the rails a little bit toward the end, so we're gonna go ahead and switch off. Whew. Has anyone seen what's been happening to GameStop lately? We're scheduled to talk about it. We're scheduled to talk about it at on Monday. But if you don't know, there is some interesting stuff happening with GameStop right now in the world of financial markets. You have stock? I considered buying myself a share. I usually only do ETFs because they're much safer. But I thought of splurging on my budget a little bit and grabbing a share of GameStop to join the party. It is so what's happening to GameStop is a really funny and crazy example of a short squeeze, which is itself a crazy situation in which people who bet that a stock would go down get really wrecked. So I do not recommend getting yourself into this situation, and I would probably stay away from the stock right now, but you can do whatever you want. I do encourage you to look into it more because it is absolutely hilarious what's happening. It's not very funny for the hedge funds that are involved with the stock, or the big financial institutions that are getting wrecked by a subreddit. It's a funny story. We'll talk about it later. You bought at 40? Well done, well done. I do recommend you get out though. Don't tell anyone I gave you that advice, and frankly, you shouldn't be taking my advice. I'm not a financial analyst or anything like that, but yeah, I don't see this ending very well. Okay, let's get back to it. Go ahead and quiet down, Sonic. Okay, so let's get back into it. So we, I want to, actually, let me go ahead and load a game up. Okay, let's get a game load up. I'll be back in just a second. The AFK button here. Okay. Let's go ahead and get Steam rolling. The lecture agenda may be found on Canvas. You go to the schedule, which is one of the first few links on the Canvas homepage, and then you can find every lecture agenda for each day of the course. Okay, we're back. Okay, so how many of you, chat, how many of you have heard of a game or played a game called Scribblenauts? This is actually a franchise with several games in its catalog. Yeah, Scribblenauts on Steam. Yes, this is Scribblenauts Unlimited, one of the latter, kind of later iterations of the game. It has some cool new features we'll talk about in a sec. Let's go ahead and play the game. Okay, so this is Scribblenauts, and I need to delete some of this stuff. Hold on. Would you like to pet the Lovecraftian puppy? Can we? How do we delete stuff? How do we delete stuff? I have no idea how to. Oh, rest in peace then. We got an acid cloud here. I have no idea how to delete stuff. This is a big problem. I'm just gonna move it. Oh, there we go. Sorry, puppy. You'll be fine. Okay. So this is an interesting game. One of the biggest mechanics of this entire franchise is the idea that PETA is the idea that you can add anything to the game that you want to, if only you can spell its name. And so, chat, I need some objects. Say something, chat. Wand. We got a wand. Okay, let's see what wand gets us. Here we go. A wand. Hey, there we go. There we go. We got our magic wand. Let's go ahead and pick that wand up. There we go. Okay. Cheese. Cheese. Absolutely. There we go. We got some cheese here. All right, you know what really loves cheese? How about a mouse? An animal. Referring to the animal, of course. And the mouse ate the cheese. There you go. EECS 494. That's a proper noun, so it's not going to work. A Lovecraftian puppy. Nah, none of those. A bad rat. What else? A cheetah. Okay. Is that how you spell a cheetah? Well, that's cool. But, oh my gosh. What is this stream rated? Okay, so here's the thing though. I don't really want a cheetah. How about a flying cheetah? There we go. We have ourselves a ghost cheetah. How about a piece of cheese, but oh, what else? How about a stinky big cheese? All right, here's our big cheese. Does it smell? Look at that. Look at that. Yes, it does. Okay, what other fun adjectives can you think of? I wonder if skeletal will work. So let's do a skeletal house. There we go. Do you see the bones inside of this house? Do you see the bones, everyone? That is definitely a skeletal house. Let's see. Maybe astral? Will they know that adjective? How about astral lemur? I don't know what's so astral about it, but it just got eaten by the stinky cheese. So that's pretty crazy. Okay, so here's the thing, right? How on earth would you engineer a game like this? This is absolutely incredible when you think about it. There are a ton of objects. It's hard to look through the dictionary and find something that isn't in this game. But this game also supports adjectives. So you might have a cheetah, but you could have a flying cheetah. You could have a flying zombie cheetah. How about a flying zombie large cheetah? How about, no, not a cheetah. We already have one. How about a rhino? There we go. It's our flying zombie large rhino. Okay? Absolutely incredible, the engineering and the techniques that went into this. But that's the question that we need to answer. We're engineering students, right? It tugs at you. Okay, gosh, how did they make that? So let's go ahead and explore that. All right? So this is actually the job talk that I gave to get this job. And so I apologize. It's going to be a little bit of a different format that you're used to. Scribblenauts was a 2009 game created by Fifth Cell and Warner Brothers. Now what's interesting is that Fifth Cell, the people who made this game, they were not huge. They were not a huge studio. I think at that time they were like 50 people, okay? Which is kind of small by studio standards, especially for games with this much content. The idea was you can create any object by typing it, and I mean any object by typing it, okay? You can write, oh, how about a professor, okay? And there's your professor. What about jackalope? It's in the game, right? And so it's really, really impressive stuff. There are even adjectives, as you just saw. You can have a huge jackalope. You can have a huge, smelly, skeletal jackalope. You can do all sorts of stuff. So the question is, how on earth would we build something like this? And the answer that you might come to is inheritance, right? I mean, when it comes to reusing assets, reusing code, reusing ideas and technology, inheritance is kind of the main way that you know how to do that. You learn it in 280, you use it a lot in 281, and you can use it a lot in 494 as well. It's a good idea. It's a very, very popular method of code reuse and has wide support. Almost every language under the sun supports it very well, and this is the basic usage. You have an inheritance hierarchy, an inheritance tree you might call it, where you get more abstract as you go up and up the tree and more specific and niche as you go down, okay? So human and rabbits might be objects, and a professor and a student might be a human, a jackalope might be a rabbit, okay? And you implement this in C++ with code that sort of resembles this, okay? You have a base class, you define some values and some functionality like happiness, interests, eat, sleep, talk, and then in a derived class, right, a professor is a human, a student is a human, you can actually customize and change what that functionality does, okay? If you need to. So here is a scenario for you, everyone. Here's a scenario. Okay? You have a panda. You're making a game congratulations, you've joined the local studio. You've joined 494 Soft, okay? And your boss tells you to make a panda, okay? Well, you want to reuse code, and you're probably going to need to make other things that are similar to a panda. So what should you do? Well, you create an inheritance hierarchy. Okay, you start using inheritance to share code. You create an ISA relationship. A panda is a bear is a mammal is a living entity is an object, okay? Next, your boss walks into the room and says, you know what? Frozen just came out, and I'm really thinking that I want a frozen panda, okay? Our game really, really needs it. The customers are gonna love it, okay? So what do? Well, where can you put this, chat? You need a frozen panda. So where do you put this in the inheritance hierarchy? Well, one place you can put it, fairly straightforward, right? A frozen panda is a panda. Okay, a frozen panda is a panda. So let's just put it right down here. And this makes total sense. It works very, very well, right? The ice panda has all the functionality and features of a panda, but with some additional ice features on top of it, okay? Then you have a boss who comes in, just finished watching American Horror Story or something, and says, you know what, we really need a Lovecraftian panda, okay? So where can you put the Lovecraftian panda so that you reuse the functionality from the panda, but you get to add some additional functionality for the Lovecraftian features? Where would you put this, team? Yeah, a child of panda. You got it, sub Han Solo. So a really good place to put this is right here, Lovecraftian panda, right? Because you get all the functionality of panda. You don't want any functionality related to ice because you're a Lovecraftian panda, not an ice panda. So you can put it right here. You implement the Lovecraftian parts of this and you're good. Okay, then disaster strikes. Your boss comes to you and says, okay, we really, reptiles are in. Godzilla's coming out soon. I want a ice snake. I want an ice snake in this game. Can you do it, chat? This sounds like it should be really easy, right? Hey, it's just an ice snake. How hard could it be? We already have ice functionality. We can add some reptile functionality, right? Well, Okay, so where do we put this, everyone? Where does the ice snake go? I'll give you a little bit of time to think about this, because the answer is not obvious. Under living entity, right? Okay, we've got two people saying living entity. Go living entity, reptile, snake, ice snake. Okay, well, okay, here's something to consider first. Here's an alternative to that. We'll get to that other approach in a sec. Here's a place you could put the ice snake, under ice panda, because you want to get the ice functionality, right? You've already implemented ice functionality down here in ice panda. If you put the snake someplace else, you're going to miss out on that ice functionality. You're going to copy and paste the ice code, okay? And that's really, really bad. So ice snake, this is what your inheritance hierarchy would become at the very bottom there. However, this does not work at all, right? Because suddenly you have a bunch of panda code in your snake. That doesn't make any sense at all. You have mammal and bear code in a reptile. This is a horrible, horrible design, okay? This makes no sense at all. Okay, what about under reptile? We had a few students suggest this, and I agree. It's one of the most kind of natural places to put this. So let's do it. Okay, we create a new reptile. A reptile is a living entity right alongside mammal. And then under that we have snake, and then under that we have ice snake. Perfect, right? Well, actually, no. Unfortunately, this doesn't work either. Why does this not work? It doesn't work because now we have duplicated ice code, okay? Ice is implemented within ice snake in this part of the inheritance tree, and ice is also implemented within this part of the inheritance tree in Panda. Okay? If you think back to 280 and 281, one of the things that you were always encouraged to never ever do, you never ever wanted to copy and paste. If you have a piece of logic, you were told in 280, put it into a function and then use that logic from many different places. The reason you're told to do that is a principle that's very important. It's called dry. Have you heard of the dry principle? Okay? Have you heard of the dry principle? Dry stands for don't repeat yourself. You only want one source of truth, because if you write a piece of logic in two different places, for instance, if you have some ice code in the ice snake class, and you have some ice code in the ice panda class, and they're both essentially the same, well, if you fix a bug in one of these places, you have to remember to fix it in every place. And if you don't, you're in big trouble, right? That's a copy-paste bug, and I'm sure you've run into those a ton of times, all right? You generally want to respect a dry. Don't repeat yourself. Have one source of truth for a piece of logic or a piece of data, or you're going to generate a ton of bugs, okay? So anyway, this violates dry. We've got ice functionality up here, and we've got ice functionality down here as well. So that's no good. It won't work, okay? How about under ice object? So we're going to create a new type of object, all right? And we're going to create ice snake under here. But then where do we put ice panda? Because we already have ice panda down here. We can move ice panda up underneath ice object, right? With all the other icy objects. But then it's not under bear where it should be. It's not under mammal. So we lose the mammal related code, okay? This is all a mess. It just doesn't really work. And here's a question. What happens if our ice panda decides to melt? There isn't an easy way that we can move our ice panda out of this inheritance tree to just be a normal panda. We can't really adjust inheritance trees very easily in most programming languages, okay, at runtime. We can do it at compile time, though. So this is super, super nasty. Inheritance just isn't working for this set of objects, and it should, because this is not a crazy set of objects. We should be able to get it done, but we just can't. The inheritance hierarchy, we have to sacrifice and choose a suboptimal result somewhere. And this situation where inheritance structures just don't work very well, tree structures don't work very well, is way more common than it seems. Okay? Now let me know if this experience has ever happened to you. You're going through your file system and you're trying to sort it, okay? Your file system is mostly an inheritance tree-based structure. You've got folders that lead to other folders and files that go inside of them, okay? Let's say that you're trying to organize your desktop and you've got a folder for boat information, you've got a folder for car information, and it's going really well. You put the cars in the car folder, the boats in the boat folder, until you hit this, okay? This thing. Okay, and now you're starting to sweat, okay? Because is this thing a car or is this thing a boat? It is literally both, but the tree structure cannot handle both, okay? You can't put this file in both places, and that's a problem, all right? So here's a potential solution some of you might be thinking about. What about multiple inheritance? The idea that this snake should inherit from ice class, and it should also inherit from the reptile class, okay, to get both functionality. Well, as it turns out, multiple inheritance, like what you're seeing here, is banned by a ton of popular languages, okay? And when something is banned by the most popular languages out there, you should probably ask yourself why, okay? So multiple inheritance is not a really great solution in many cases because of what's called the deadly diamond. So imagine this situation. You have a human that has a function called sleep, okay? You have a student that derives sleep, okay? And changes it, because students don't sleep all that much, all right? And you have an instructor that derives sleep because instructors don't sleep as much as students, but they sleep less than normal humans, okay? And then, this is all fine and good, right? This is what you'd expect to do in an inheritance tree. This is great. But then one day, you decide that you have someone who is both a student and an instructor at the same time. This was me when I was giving this job interview. I was still a grad student while I was teaching 494. Okay, and now you have a huge problem Because you have a class that derives from two different classes that override the same thing. Do you want to take the student version of sleep, or do you want to take the instructor version of the sleep function? Okay? This is called the deadly diamond, and it leads to a bunch of pain. I believe the compile errors just never stop when you do this kind of thing. Anyway, multiple inheritance. People typically advise to stay away from this. Okay? So we need a new approach. All right? We need a new approach. And one option for us is something we've already seen a lot in Unity, composition. Okay? It's the idea that we have a bunch of tiny components that we combine together in unique ways to get the functionality and reuse code. If you want to reuse a piece of functionality, like a piece of functionality that gives you ice, an ice aesthetic, then you have an isIcy component, and you add that to whatever game object that you want to make icy. That's it. You reuse that component. So here's the idea. Instead of an inheritance tree where a dog is a mammal, you use a has-a, okay? Entities are made up of components that provide functionality. A dog has mammal traits. A dog has fur. A dog has health. A dog has hunger. A dog has 4 legs. So 4 leg components, maybe. Here's typically how it's actually structured architecturally. You have an entity class. This is equivalent to your game object, okay? This is your game object class in Unity. And this entity is going to have some list of component class, okay? And this would be what you see in the inspector, where you can add components to a game object in a list, okay? And so maybe your entity, right? Your entity is a panda or a snake game object. Well, you have a ton of components, right? Like the ice component, like the fiery component, the mesh render component, that all derives from component class, okay? That means you can throw them via the magic of polymorphism into a list on your entity, on your game object, and each of these components can have some life cycle functions that they inherit from the component base class. Something like start, update, clean up, on destroy, on became visible, stuff like that, okay? And this is what you see in Unity, okay? You have a sine wave movement class, for instance, a sine wave movement component that derives from the base component class. In Unity, mono behavior, it essentially just means component, okay? It's just a strange name that they chose. And you get your lifecycle functions, right, that are automatically called and stuff like that. Okay. Well, one of the cool things, again, is if you took this component right here and added it to a turret, you get a flying turret. But you can reuse the component, right? The reuse is the key. You reuse the component anywhere you want. So if you want a floating platform, you can put it on there too, okay? And it just works. All right. So how would you create these characters that we needed before with the composition approach rather than the inheritance approach? Well, for the panda, you might have some components like fur, carnivore, living. Okay, so it has HP, it has hunger, it has other stuff within that component. A render so we can see the darn thing, right? It might have a herbivore component. Notice that pandas, right? If we want to make a panda that only eats vegetation, we just don't add carnivore. If we want to create a murderous panda that only eats flesh, then we get rid of herbivore and only put carnivore on. To create a true panda, we add both of them. They're not mutually exclusive. Okay, but if we then want to take this panda and make it an ice panda, then we need an icy skin component. We just add it to the panda. We get these other components, and there we go. If we want this panda to melt later on, we just take this component and we remove it. Some of you have probably seen the destroy, GameObject.destroy function. That's how you remove components at runtime from game objects. So it would be very easy to make this icy panda melt. Okay. There's a question from Ying Lunlo. Can we combine has-a and the is-a method? And the answer is yes, and I'll show you that in just a sec. Very powerful. Inheritance and composition work together extremely well, okay? Okay, let's keep going though. If we want to create a panda, a zombie flying panda, a Lovecraftian panda, then we would want to add zombie skin, and we don't want to add the flying component, okay? For a snake, we'd want to add some snake and reptile specific components. but we can reuse that ice skin component from earlier, okay? We can reuse what we created for the panda, the ice panda, to create the ice snake, okay? And so compare these two structures. ISA, right, where you're kind of locked into the structure. You are you're beholden to the structure, right? And it forces duplication to happen. Ice snake over here, ice panda down here. Here with Haza, you can simply customize as you see fit. And over time, you add to a toolbox of components, okay? So the old questions of where does the ice snake go? What happens if the ice panda melts? They're super easy to answer with this alternative approach to reusing code and logic, all right? Here are some bonuses. How do you make a scaly panda, right? Well, you already made a scale component for your snake. So take that scale component and pop it onto the panda, okay? How do you make a flying zombie snake? Well, we take the zombie skin that we made for panda, we reuse it on snake. Take the flying component we made for the Lovecraftian panda, put it on the snake. Boom, done, all right? And so what you'll notice is that we're building up a toolbox of components that we can reuse anywhere we want. We can mix and match them. And if these components, if they're coded in a really safe and conservative and flexible way, then we should be able to just pop them onto anything and it should just work, okay? It shouldn't be throwing areas. It should check what other components are around and communicate with them if necessary. And so writing good, reusable, and flexible components is going to be a very, very important challenge for you that you're going to start to get the feel of on Project 1, okay? So, question, what if you have a non-technical teammate? Well, composition still allows them to do some really cool stuff. For instance, it should be fairly easy for a non-technical game designer teammate to enter into your Unity project, look at your player game object, look at your panda, and say, oh, okay, what components do I have? Click on the add component, see that big list of all the components that you've made, and then pop the one on that they need, okay? So in a way, this approach is very, very nice because you don't have to have your game designers go into the actual code. They can just look at the components that are available, mix and match them until they get something that's interesting, okay? And here's a question for you. Here's a really interesting question. In the bottom left corner of the screen here. Question, does zombie skin and ice skin being in separate components violate dry? Because remember, we violate dry whenever we have a logic that's duplicated in multiple places. So here we have a component that is called ice skin, and we have a component that is called zombie skin. These both are related to skins. We also have, no, that's it, pretty much. And so we have skin functionality that is duplicated in two different components, right? So that's a problem. How do we get past that? Well, the answer is this, okay? We combine ISA and HAZA, okay? We have two components, zombie skin and ice skin. They both are skin-related components, and they share that logic. So how do we make sure we don't duplicate that logic in two different places? We use inheritance. We're back to inheritance. So you use a very simple structure like this, okay? Now your skin-related functionality is in one location. So if you have a bug with how skin works in your game, you fix it in that one place, boom, every single component that is related to skin gets that upgrade, and we're good, right? And note, we're using inheritance with composition, okay? They are very complementary and very powerful if you understand both of them. Or to put it differently, this lecture has put a new technique in your toolbox. You can use inheritance, but you can also use composition, and you can use them together, okay? The more tools you have in your toolbox, the more rounded, more well-rounded of an engineer, the more flexible you're going to be when it comes to tackling interesting challenges, okay? Okay, so let's keep going. Composition is a topic discussed in all sorts of design pattern books. It happens to be kind of the dominant pattern in Unity, but inheritance has a place as well. There are lots of different places you can go to learn more about this approach. The Sims had this. One of the interesting things, if you've heard of The Sims, if you've played it, one of the big features of The Sims is you have characters, little humans called Sims, and you have a ton of objects. So you might have this slip and slide. You might have a barbecue. You might have a radio. You might have a table, a chair. And when it comes to the game designers deciding okay, what should the player be able to do with this 3D model? We got this 3D model of the stereo. What can a character do with it? Well, adding components is a way that you add affordances and things you can do, interactions with that object. So there might be a component on this radio like listen, listen to, or listenable component. And then there might be another component on here that is danceable. So you add danceable to a component and the sim can walk up and start dancing next to it. You could add that component to the table, right? So the sim could walk up to the table and start dancing near the table. Doesn't make much sense, but maybe it would in like a wedding scenario or something. I don't know. Yeah, one of the fun things I worked on when I was at The Sims was a waiting line component that actually lets people go to an object, be intercepted by another sim using that object, and wait and queue up on it. So that was pretty cool. How do we get composition? So composition in Unity, it's a big thing, right? We showed that already. The components on any game object is this list. It's shown off in the inspector. Okay, you can turn components on or off to make their lifecycle functions not run. For instance, if you uncheck this box, you will have your update function stop running on that component. You can mix and match components. For instance, if you wanted to have this turret shoot periodically but not aim at the player, you can turn off this component, aim at interests, and it'll just shoot in whatever direction it's currently facing. If you want this turret to look at the player but not shoot ever, maybe like an NPC, maybe like a friendly turret that's just kind of checking you out, saying hi, okay? Then you could turn off shoot periodically, but turn on aim at interests, okay? So mix and matching components can give you some really interesting behavior really quickly, okay? There's some examples you can find online that I've created of how you might program a composition-based system in C++ instead of in Unity's kind of built-in C# approach. It's not very efficient, but it's kind of interesting if you want to check it out. So here's the summary. Here are the takeaways. Composition is a flexible alternative and complement to inheritance. It can be mixed and matched at runtime, which is super powerful. Remember, game design is a space that requires as much iteration as possible. The faster you can iterate, the better your game design is going to be. And this is almost without exception, okay? So the fact that you can go in and you can customize stuff, right? You can just say, you know what? I would never want to make a fiery priest character, but I've got this priest character and I've got an is fiery component. Why not? Let's see what happens. And then you put it on, you're like, wow, that's way more compelling because now the priest shoots fireballs and it's like, wow, is this like a demon priest? And like, wow, right? And so that kind of experimentation and quick iteration and customization is where the best game design ideas will be found. So it's very, very important, and that's why it took the focus in Unity. Okay, great for scenarios involving properties and experimentation. Here's something that I recommend. Okay, in the exact same way that Scribblenauts down here in the left corner was able to use adjectives. Okay, adjectives in this game are essentially components, right? So we could describe a panda as fiery. And when we spawned it in, it would spawn in as a panda game object that had a is fiery component on it. Okay? So whenever you create a component in Unity, think about how you name that component. Chances are that component can be described as an adjective. Okay? Does follow player control. Okay? Sort of what is that? A compound adjective? It's adjective-y, right? Has arrow key movement, right? Has health, has inventory. These can all be components, and they have a very, very simple job. A has inventory component is simply going to have a few floats in it, or maybe to control to track how many rupees you've got, to track how much HP you've got, maybe, or what weapons you have. That component can then have an on-trigger enter, so if the player touches a rupee, your has inventory component will increment the rupee counter, right? The cool thing then is it doesn't say anything about being on the player. So your has inventory component could be put onto an enemy. And now the enemy can collect stuff, right? And maybe you add additional functionality. When you detect the player has died, the has inventory component needs to spawn in those items that you were holding, so it looks like you spilled a bunch of stuff when you get killed, right? So anyway, think when it comes to designing, okay, what components are we going to have? Team, what components are we going to have? Think about adjectives. Okay, a player game object has grid movement, but so does Stalfos. So if we create this has grid movement component, then we can use it on the player, we can use it on the Stalfos enemy, you can use it on the Goria enemy, and save a lot of time that way, all right? Anyway, components, adjectives, okay? Think about that. It can work very, very well with inheritance, so don't give up on inheritance entirely. If you notice that you're creating several components that share a lot of code, you might want to create a base class for that component, okay? And derive it. And that's essentially all I have. There's some other stuff here that was related to my job talk that is not very relevant here. But we'll talk about some of this research, game dev research stuff later, okay? There's actually a game dev research course you can take after this one if you want to. It's EECS 499, section 210, where you can go and explore a niche area of game dev and have a good time doing so. Okay, so I think that's just about everything I wanted to get to today. We moved pretty fast. I do want to give you some cool tips, okay, and tools that you should use. Okay, so communication is one of the most important things you can possibly think about and work on in this course. You're going to be working with other team members, and your communication can be very efficient. It can be very sluggish. If you send someone a piece of information that they don't understand, this is a really expensive issue because you then need to have a back and forth. Every time you go back and forth, there's a big latency involved with that, right? Someone might need to use the restroom. Someone has to type it. Someone, has to try and figure out what you're talking about. So anything you can do to improve communication among you and your team members is critical and worth investing in early, all right? A really cool tool that we can use is ShareX, okay? This is an open source tool. Unfortunately, it's only for Windows, but there's some Mac alternatives that are kind of similar. Here is the magic of ShareX, okay? Okay, I'm working on my game. Here's the game, all right? Oh, I've got this big bug. That I don't understand, and I need to ask my teammates about it. So I'm gonna take a video, hotkeys, boom. I'm recording this video, right? Oh, come on, start up, there we go. I'm recording this video of this guard here. You see, it doesn't quite look right. It's got this tint that I didn't want. I'm not sure why it has this tint. Okay. So I've recorded this video, and that took about 5 seconds. And now, boom, it just finished uploading my video. And we're going to go ahead and it also copied the link to my clipboard. So now I'm going to send this link to my friends, and they can see exactly what I saw, right? And that entire process took about 20 seconds, okay? So record video, it automatically uploads, it automatically puts it onto your keyboard, and you just send it through Discord or through Piazza or through email to send it to your friend, okay? Let's say that I want to quickly, I found something super weird. I really don't like this design. I wonder what my teammate meant when they put in this design where there's two right next to each other. So Control-Shift-4. Hotkey, take a screenshot. The screenshot is uploading. It uploaded in the corner, and I just send it to my friend. Boom, screenshot, done. That simple, that quick. You don't have to go find a separate program. The hotkeys are fantastic. It uploads, so you don't have to worry about sending it into a Dropbox folder or something. You can even upload a GIF. So let's go ahead and record a tiny GIF here. Control-Shift-3, we're recording the GIF. A quick go around there and stop. Okay, we click stop. It's uploading 58%, 78%, 90%, and there we go. It's finished uploading. It's put on my copy-paste clipboard, and I can just send it right there. I can put this on Twitter if I want to. I can post this to Piazza so that the instructors know what I'm talking about when I talk about my issue. Hey, it is super, super great, and it's right here in the agenda. It is it is ShareX. Here's the link to it, getsharex.com. It's open source, it's free, it's super, super powerful. So I highly encourage you to use this. Now, it might sound like, hey, I'm just kind of shilling here, but hey, think about it, okay? Tooling is extremely, extremely important. Processes are extremely important, and they get more important the more you use them and the more fundamental they are, okay? There's probably nothing more fundamental than working on a big project than communication with team members. Okay, you'll be doing it every single day, multiple times while you work on Project 1 and Project 3. It behooves us. Like, the earlier we can make that an efficient, short, brief, and effective process, the more we're going to gain from that. Okay? So anyway, it's worth investing in tooling and processes at the beginning of a project because then you have the entire span of that project to reap the benefits of that efficiency, okay? If you adopt tools like this only when it's too late at the very end of the project, you're not going to get any benefit from it. The project's just about to end. It's not going to be worth the investment to set this up. And it's very, very easy to set up, so don't worry too much. You can configure it to upload to Google Drive or Dropbox or whatever. It's very nice. If you're on Mac, unfortunately it won't work. However, there is Lightshot, there's Moonsnap. You have alternatives to ShareX that can get you to a similar level of productivity, okay? So anyway, that's the main takeaway. For any tool, for any process, you just want to make sure you're thinking about these things, okay? All right, so what else? I think I'd like to do this. I want to give you some time. I want to give you about 5 minutes to ask any questions before the end of our normal class period. On Monday, we're going to be going through some design patterns that might help you on Project 1. Regrettably, we can't get them to you for this first sprint here to Monday, but we will get you some design patterns that should help you a lot as you try and scale out this Project 1, okay? You're going to discover that you make some mistakes on your architecture on this first project. That is very much the point, okay? You go into the project, you do it one way, and you discover, wow, these are the weaknesses of my current approach, okay? I should work to mitigate those weaknesses with a new architecture and a new approach that scales a lot better. We'll talk about this on Monday, and hopefully by that time, you'll have a visceral feel for what takes you, for what is an inefficient approach, okay? So anyway, look forward to design patterns on Monday. And some advice on how you should be approaching the scale out of we need to create 5 enemies, not 1. We need to create 5 weapons, not 1. Okay? So look forward to that. Okay, some questions. Anytime we include a screenshot in a Piazza post, do we need to make our thread private so only instructors can see it? No, you don't. So we don't want you sharing a screenshot of your code publicly. But if you have a bug or an issue, a defect that you can see in your game, then yeah, you should share that. Take a screenshot, show that off. It's very likely your team members will be running into a similar issue. So as long as you don't share code, we would be happy to give advice and tips on how to resolve the issue so that your teammates can benefit as well. I sent an email to staff for a Jira invite. When should I expect it? Tonight, right? So I can't fill those requests until I'm done teaching, which is going to be around 4:30. So it'll probably happen sometime this evening. So don't post screenshots of your code, but you can show us defects like my project is doing this. Do you have any high level advice for how to resolve it? Okay. Okay, Gary, just want to be safe. What video hosting server do you use for ShareX? I use Backblaze.com, which is one of the cheapest file storage solutions I've found in my attempts to be efficient. Backblaze is very, very cheap. You can think of it as kind of a replacement for Amazon S3. It doesn't have the same reliability guarantees, but most of the stuff we put through ShareX doesn't have to be reliable, so it's fine. Okay. Is there a version of Unity we should be using? Should both partners work on the same version? The answer is yes. That's a very good point. And actually, that's something I should add in here so that we don't forget to say that next time. Unity collaboration setup recommended. Have entire team use same version of Unity. In this case, you also want to make sure you're using a version that's unlikely to be buggy, because if you grab a beta version of Unity or a more recent version of Unity that hasn't had a lot of hotfixes, what can happen is you run into a bug that's really nasty, and you must change your version of Unity. That's easy enough to do when you're on a one-person team, but when you're on a four-person team or a two-person team, if you change your version of Unity, that forces everyone to change. And so I recommend that you settle on a version of Unity that is pretty. It has a bunch of hot fixes, which is to say, it is. You should probably use the LTS, the most up-to-date and recent LTS version, which I think is 2019.4. I think there's a new LTS version coming out pretty soon, though. I think a lot of people are using 2019.4. The 2020 and 2021 versions of Unity have new features, but for in almost every case, you don't need those features, particularly for Project One. Any more questions? Anyone? We'll stick around for about. Actually, unfortunately, I do need to bail to prepare for the 2:30 section of this course. So I will. I'll throw on some music, and I'll sign off for just a moment. Thank you so much for joining us, everyone. I apologize for the voice a little bit, being a little bit under the weather. That's okay though. And we will see you on Monday. Have a fantastic weekend, and don't be afraid to make contact on Piazza or Discord if you're not quite sure what you should be doing, if you're feeling a little bit overwhelmed about Project One. Okay? Good luck. You can do it. Buckle in. The next couple weeks are going to be pretty tough, but you're going to learn a lot, and you'll come out the other side feeling really, really confident, or at least much more confident in your ability to engineer games and interactive experiences quickly. Okay? So we'll see you then. Bye-bye. I'm muted. Oh, can you believe that? I feel like this happens at least 3 or 4 times per semester where I'm muted, not on purpose. But hey, it's great to see all of you. Thank you for joining us. I hope you have had some time to relax, kind of freshen yourself up a little bit, maybe get ahead in some of your other courses. And I just hope you're feeling pretty good, feeling pretty confident, right? For this big day, right? The start of your Project 1, what many would describe as the hardest part of the course. So we're going to be doing exactly that. I want to apologize ahead of time. It was a very nasty night for me, very sick. So I'm a little bit under the weather this morning, but that's okay. We'll get through it. Today, we're going to focus on Project 1 and explaining kind of what it is, what you'll be doing from now until Monday. And we're also going to give you a little bit more insight into what does composition really mean? What does it mean to build a project out of reusable components and to engineer components in a way that's going to make them effective and reusable, right? You might be very used to using inheritance when it comes to code sharing and reusing logic and making sure that you only have one piece of logic in one place, right? So you avoid copy and paste bugs. We're going to dive into that topic today and also introduce some new technologies that are pretty cool, such as raycasting as well. So let's go ahead and get into it. We have a few announcements as we begin here. Tomorrow, IGDA Ann Arbor is hosting Maxwell Perot, who is a former EECS 494 and Wolverine Soft student. In fact, he was still a student here not so long as a year ago. So we'll be hosting his presentation online, kind of covering the topic of how he went from Michigan to Wolverine Soft to joining one of the biggest game productions on the entire planet. I believe Roblox is just smaller than Fortnite and now bigger than Minecraft in terms of its active player base. So it's going to be a fantastic talk. I hope you'll consider joining us online to watch it. This agenda is posted to the schedule, so you can get to it right now if you would like to follow along today's lecture. Let's keep going. How many of you, a quick question, how many of you have played a game called Final Fantasy X? Final Fantasy X is a classic JRPG game from Square Enix, but it does a very interesting thing in how it deals with progression. So it looks like a number of you have played Final Fantasy X. Typically in an RPG game, if you think back to Pokemon, you fight a lot. When you complete a battle, you get experience. When you get enough experience, you level up. What does a level up even mean? Well, it means your stats increase. So your HP goes up, your attack goes up, your defense, your special attack, maybe get a new move. And that's usually how it goes. It's a very simple and understandable approach. Final Fantasy X does a really interesting thing. Every time you level up, you don't get any stat bonuses. Your stats don't level up or increase at all. But what you do get is you get a resource that allows you get a move. You get one move per level that lets you move along this game board, okay? And this game board, depending on where you go, what routes you take, how far you go, every step you take changes your stats a little bit, gives you an upgrade on your HP, or maybe you can go this route and focus on attack versus defense, create a glass cannon, okay? And as a result, many players, when they played through this game, felt like progression was a lot more interesting because they could kind of customize and tailor their characters by choosing the path that they decided to follow, okay? What's interesting is that if you go online, generally, you can find a lot of really good analysis of game design topics. If you have a game out there that is moderately popular and does something very interesting, you should expect to find a few intriguing and insightful blog posts exploring that aspect. This is one where someone went in, took this game board, which is called the Sphere Grid, and it looks like it's so crazy and full of options and different routes and choices you can make, right? Look at this tangled web. You can go anywhere. You can customize your character in any way, right? Well, as it turns out, it looks like this web of many different decisions. But if you straighten out the paths you can take, they actually look like this for each different character, okay? Surprisingly linear in a way. Now, this isn't quite accurate because toward the end of the game, you can get special orbs, items that allow you to jump from any location on the grid to any other location. But it's a really, really interesting kind of topic on it's a tangent on the power of presentation, right? If you see an upgrade path that looks like this, very linear, straight line, it's not very exciting, is it? If you see an upgrade path, a map that looks like this, whoa, imagine the possibilities. The power of presentation to make you have a certain experience, regardless of how authentic that experience really is. Anyway, that's just an interesting little deep dive, or a little shallow dive, I guess, into Final Fantasy X and progression systems. If you work on an RPG for your P2 or P3, you'll need to think about this kind of thing. Okay, so a particularly clever deployment of augmented reality. As it turns out, like companies, as we talked about before, companies you wouldn't expect, like Pepsi, have game teams creating interesting interactive exhibits like what you're going to see right here. Okay, this is a bus kind of shelter that has an AR exhibit that surprises people. It doesn't tell them that it's AR powered. So a meteor shows up, and the lady's like, "Oh my gosh, was that real?" There is an octopus monster underneath the city, right? He doesn't look like he was fooled very much. UFOs invading the city. You can see through the side here. Like, whoa, what's going on? A person on balloons coming in. That looks really good. Anyway, just because this isn't video games, right, doesn't mean it doesn't take game design and technical expertise, right? Creating an experience, an interactive experience, it means a lot of things these days. It doesn't always mean creating traditional games. So please keep that in mind. There are a lot of companies out there who will pay you to do really cool game dev-like stuff, and you know, when you're not really working on games. So, okay, let's keep going. Reduce, reuse, and recycle. Something you'll discover about this course is that you have so little time, and this is also the case in game dev as well. There's so much competition that you really want to reuse things when you have them, okay? If you create a new mechanic or a new system, that isn't just a bunch of time you're going to lose. When you have a system, it has to be maintained. It has to be bug fixed. It has to be improved over time, right? To keep up the pace with the other systems that are moving forward. And so what you'll notice is that even AAA teams with a lot of resources will reuse stuff as often as they can. Here's an example from Super Mario Galaxy, where the team needed a way to make a door give you dialogue. Now, they already had a system that sort of did this. They had the signage system, where Mario walks up to a sign, presses a button, and a little dialogue exchange happens. But they didn't have an ability to give this property to a door. It only worked on signs. And so, here's what they did.
For time. At the beginning of the Good Egg Galaxy, there's a house with a note attached to the door reading "Gone for a long time. Need to get in? Use the pipe on the other side." Instead of the door being readable, however, the developers took a shortcut by placing a signpost behind the door, just close enough for Mario to read it.
Right there. Fantastic. What is the difference between creating a new door system that allows you to interact and talk with the door versus just placing a sign behind the door and fooling people into thinking they're reading the door when in reality they're reading a sign? It's genius, and it saved this team probably a lot of time because they already had the sign system. They were using it in a lot of different places, so they knew it worked well. It had been used a lot. It was bug fixed. Just fantastic, right? This would be where the famous phrase "work smart, not hard" comes in. In this course, you'll have to do both. Okay, let's keep going. A not so rare instance of overscoping in the wild. This is definitely tangential, but a pretty fun thing. When it comes to game development, you can go work for a big studio, or you can go set out on your own. You can create a startup that creates client work. For instance, Arbor Interactive is a startup that actually makes games for other people. you might be a YouTuber brand on YouTube. The company that we made a game for was doing children's meal prep videos. And you might decide that, hey, we do videos, but I want to get our brand and going with interactive media. So why don't we hire another company to make a game for us? And so that's what happens. Now, here's a client that came to us, and they said they had money and they wanted to have a game made, but they didn't have any details. So we asked them, hey, do you know what kind of game you want to make? Do you have any themes, any general, any knowledge of genres that you might want to incorporate? And this is the response we got. It's a knock and run game. The genre would be fighting game because you will be able to do it all. And this is maybe it's one of my favorite lines ever. So clearly this is a client that doesn't quite know what they want from the game they would be purchasing. This is a client that wants the player to be able to do it all. And at Electronic Arts, we had a name, a term for this kind of game design where, hey, you should be able to do just about anything you want. It's like real life, right? This is called the everything game. And this is the kind of game that you often hear pitched from very, very early game designers, right? Oh, we're going to have this big world, and it's going to have fighting game mechanics and it's also going to have an RPG system. So the more you fight, the more moves you unlock, and the stronger you get. But actually, it's going to be set in an open world, so you can explore, and so your fighting has all this context, right? And you can explore, and you're not just fighting in an arena, you're fighting on the streets of San Francisco. And it's San Francisco, right? So we're going to have schedules for the inhabitants. NPCs walking around. It's going to walk around, and they're going to have their own jobs that they go to, and sometimes they have to go home to sleep. And you know what? We got this big world, but no players to put it in. So let's make it an MMORPG. So we're going to have thousands of players running around the city at the exact same time. And yes, and soon you'll be able to build a spaceship and go to different star constellations and galaxies, and then you end up with something like Star Citizen, right? Which has so many different things in it, and so few of it works for the longest time. It's the everything game. It's impractical to make, and it's a very it's a warning sign of a designer who hasn't had a lot of experience. In this course, typically you want to focus down. You want to focus down on fewer mechanics, make those mechanics extremely polished, and make them work together to create something that is more than the sum of their parts. That keeps your scope in check, so you can actually produce that kind of thing, right? There's enough time, and you have enough energy and resources to do that. And it allows you to just refine. You don't end up with a huge game that has a bunch of unpolished stuff in it, which no one wants to play, okay? Anyway, avoid the everything game. That's the takeaway from this tangent. All right, so now let's go ahead and focus. Today, our focus is on getting your P1 started. Due today was your P1 team registration form. So this was the form that you filled out to have your team created and get yourself onto a team with a partner. Now, these are not created yet, so you'll be getting your teams tonight. You'll be getting your teams on Canvas. You'll be getting your teams on Jira. And if you already know who your teammate is, like you filled out the form, then you can start right away, right? Start working on P1 tasks, and you'll be fine. Otherwise, wait until tonight. I'll make an announcement when all of your teams are created, and then you can look at who your teammates are on Canvas and reach out and get started, okay? So let's learn a little bit more about Project 1. So Project 1 is a classic game project. You are going to be recreating a small piece of either Legend of Zelda for the NES or Metroid for the NES. Now, despite being released in 1986, these games are both still celebrated for being fun to play, for having engaging game design, and some pretty cool technical stuff going on too. So when it comes to remaking these games, essentially what's going to happen is you have a big task spreadsheet. Depending on the game you're working on, you'll have a different one. Okay? And there we go. So here's the spreadsheet for Zelda. The Legend of Zelda has quite a few mechanics that you need to implement but not too many. Let's go ahead and get our spreadsheet finished here so we can zoom out. There we go. We'll zoom out a little bit. Okay, so here's an example, right? You've got a task here. Its type is feature. It is titled Play Original Game. The description is visit Zelda at CVGA, or play it legally in some other way, or take notes on the movement, the mechanics, attacks, what enemies are there, how do things work. And you also have some hints on how to accomplish this, okay? The priority for this particular task is high, which means if you skip it, if you decide you're not going to do this task because of time, it's going to hurt your grade more than a normal priority task. And it is due at the end of the P1 milestone, okay? That's what the milestone column means. The kind of expected amount of hours it will take to do this task is 1. And if you look at all these tasks, there are quite a few. Fortunately, however, only the red ones need to be complete for Monday, okay? Your P1 milestone starts today, ends on Monday. You've got 5 days, yeah, it's gonna be a little bit of a sprint, but not too bad, hopefully. Okay, so your first objective is going to be to read through all of these tasks and kind of, with your teammate, figure out what they are, right? How are we going to attack these? How are we going to approach these? Both of these games come with a tutorial that you can just follow for the next 5 days, and you'll get a lot of these tasks done just by following the tutorial. Here's an example. This is the Zelda tutorial. You'll follow it. It will take you through some interesting technologies that you should use to make your life a lot easier, okay? It will help you create your first weapon. It'll help you figure out how to write the movement controls. One really interesting thing is as you follow these tutorials, you'll notice at the top of your Unity editor, you have a new menu show up, right? 494, do you see it? This 494 menu, right, it's pretty hard to get. We had to work our contacts at Unity to get them to program this menu for us and add it to the editor just for our course, right? In reality, that's not how it went. It's very easy for us to create our own, kind of edit the Unity editor on our own if we want to. But essentially, we've given you technology that you can use that will make it really, really easy to generate the entire world for your game. Here's the example. You'll use that 494 menu to generate the entire Legend of Zelda map or Metroid map in unique tiled pieces, okay? You can then click those pieces, you can move them around, you can add components to them to make them solid, for instance, so you can't walk through them. It'll make your life a lot easier. When I took the course, we had to manually add every single tile to this entire map, and it took a long time, okay? It was not very interesting or knowledge gaining either. Okay, so that's essentially how it's going to go. From now until Monday, you and your team member are going to be going through this task list, and you're going to be knocking them down. You're going to be putting some effort into them, and on Monday, we'll move on to the other tasks, the white ones, P1 Alpha. You'll have a little bit more time for that, but we're not quite there yet. Okay, so let's go ahead and keep going. Question, does anyone have any questions thus far? We're going to talk about the schedule for P1 next, and some of the other assignments that you'll be doing as well. Any questions so far? Okay, so let's go ahead and keep going. As far as the schedule goes, here are the dates that you need to care about. We've got today, the 27th. In 5 days, we've got February 1st. This is when your P1 milestone is due. We've got the 10th, we've got the 15th, and then the 17th is when you're totally done with Project 1, okay? And many people report the course becomes a lot more enjoyable and less stressful at that point, okay? You can think of your deliverables on this project in terms of engineering, design, and production. I'll make my window a little bit smaller. So the first thing you need to think about, and the thing you should start thinking about today, is P1 milestone. This is your first technical deliverable on this project. You'll be submitting a game build that gets played and critiqued by your instructors. You'll also be working on, starting today, a P1 research assignment. However, it won't be due until the 10th. P1 research is an essay assignment that is very, very short. I know that I know many people hear essay and they're like, what? This is an engineering course, right? Don't worry about it, okay? It's very short, and you don't have to worry about things like grammar. You don't have to worry about things like structure, okay? This is not a literature or writing course. This is an assignment where you will be tasked with comparing your Zelda or Metroid game with other peer games from its genre. The reason you do this is because you need to go out and play those games, right? Get some background knowledge on what makes these games work, what makes these games not work, and then that will inform your decisions when we get to the final part of P1 and you design your own new mechanic and your own level to go with it, okay? There's a question, should we split up the tasks with our partners, or what's a good way to approach it? Yes, I recommend you split up many of the tasks with your partners. Typically, you'll want to specialize a little bit to become most efficient. So you might have a partner say, okay, I'm going to be focusing on all the enemies, you're going to focus on all of the weapons, and we're going to share this task because it sounds really difficult, but this other task is going to be mine, that other task is going to be yours. Split it up pretty evenly, but you also want to let each other specialize because that will get you the most efficiency. So the last assignment you need to think about starting today is P1 project management. So P1 project management is where your Jira site comes in. You all have accounts on Jira, and what's going to happen is sometime tonight, you'll go to your Jira dashboard and you're going to see a project show up. We're going to create a project for you. The project is going to look something like this, okay? You're going to go in, you're going to see a board, something board, okay? And there are going to be a bunch of tabs everywhere. You'll follow the P1 project management spec, and it's going to tell you to go in and create a bunch of tasks. Okay, we're going to create an issue. What kind of issue? We're going to create a task. And okay, what kind of task are we making? Let's open up the dialog here. We've got, where did our spreadsheet go? Let's go back to our spreadsheet here. Okay, so we've got a task called grid-based movement. Okay, so we're going to copy and paste that in, create that task. So grid-based movement. Okay, so what is the time estimate here? The time estimate for this task is 2 hours. So we're going to copy that in, 2 hours, and we still have 2 hours. Okay, what are the description for this task? Okay, we have some stuff here, description and hints. We're going to copy and paste both of these in right here. Okay, there we go, and we can see them. Okay, what's the priority for this task? The priority is high. The priority is high, so we're going to say high priority, which means we should prioritize it over normal or low priority tasks. And let's see, who is working on this? Let's say I'm going to be working on this. It's assigned to me, and there we go. We'll go ahead and create that task, and now we have a little task down here. We'll say, okay, we're going to create a sprint for our P1 milestone. We're going to call this P1 milestone test because we're just doing a test right now. And then we're going to drag our task in. We're going to drag all the other tasks in for P1 milestone, and then we're going to create that sprint. I think there's a start sprint button. Oh yeah, it's right there. I can't start the sprint because I already have a sprint going, but that's okay. You'll configure how long the sprint lasts. It lasts from the 27th to the 1st of February. And then in your active sprints tab, you'll see something like this. You'll have a bunch of tasks that are not finished. They'll be over in this to-do area. And you'll be able to click on them, kind of see who's supposed to be working on them. So test user 2 is supposed to be working on that one. Who's supposed to be working on this one? Test user 2, and I guess they're all using a test user. I'm going to take that one. That one's mine. Okay, so this one is mine, set up P1 project management. I'm going to move it to in progress since I'm working on it. Okay, let's say I did 30 minutes of work. I'm going to click log work. I'm going to go 30 minutes, and I'm going to describe what I did. Okay, I went through and copied all tasks into system, created sprint for P1 milestone. Done. Logged that time. That will show up. Our teammates will be able to see that we did that amount of work. if they look into that task. And then when I'm finished with that task, I drag it over to done. If the deadline for our sprint is like 1 day away and we have a ton of to-do tasks, that's bad news, okay? If most of our tasks are over in the done column, though, then we know we're good. So we don't have to worry too much. In other words, this is the kind of thing that you'll be doing as you work. This system helps you not work on the same thing that your teammate is, right? You know what your teammate's working on. You know what's been assigned to them, what current tasks are currently progressing. That's important because a task that your teammate is working on might block a task that you want to work on, right? Maybe you can't properly work on the health system until your teammate has gotten done with the inventory system, because the two are related. Like maybe you want to use the inventory system they're working on to store HP as kind of an item or something. You don't have to, that's just an example. But anyway, you know what each other's working on, so you can keep each other on track, and you can prevent working on the same thing. That's not to say that you shouldn't work on the same thing. If you have a really challenging task, what you should do is you assign it to one person, but then you note within the task log that, okay, this person helped me with it. We worked on this together, okay? That way, when we look through your JIRA projects and try and figure out if we need to apply the imbalanced team contribution penalty, also known as the freeloader penalty, we'll see that and we won't penalize you, okay? Okay, does anyone have any question? What is the purpose of logging time? So this is the main purpose of logging time. There's a report section on the left here that I probably won't go into too much now. But this report section, because it's not going to look good in this test project, this report section will allow you to generate reports that tell you pretty accurately how on track you are. For instance, if you have 10 tasks and each one requires 2 hours of time estimate, right? Then you've got 20 hours on the hook, right? You're probably going to need to invest about 20 hours. You can look at how many days you have left via a report like this, and you can see that, okay, we're in big trouble. We're going to need to invest this amount of time, which means this amount of time per day, which means we need this meetings to happen. And as you log time, that report will start to reflect it going down, okay? So the report will become more accurate as you log time. Another thing that you want to do is, another reason time logging and time estimation is important. You might look at your calendar and say, okay, I only have 1 hour to spend on 494 on Mondays. On Tuesdays, I can spare 2. On Wednesdays, I can't spare any. On Thursdays, I have this much time, Fridays, Saturdays. And if you can gauge semi-accurately how long a task will take, and if you can get better at this over time, then you can accurately say, hey, okay, I will be able to get these tasks done given these days on my schedule. Or you might say, hey, the number of days I've got on my schedule, the number of hours I can put into this project, there's just simply not enough. That tells you that you need to cut right now. You need to cut and throw on the back burner some tasks. So, in other words, time estimation helps you better understand your production process and helps you make predictions better. If you can make good predictions, then you can be much more efficient with what you choose to work on and what design decisions you choose to make, okay? All right, let's keep going. And by the way, you don't have to remember any of this stuff because it's all in your P1 project management and P1 milestone assignment specs, okay? So you'll read through those assignment specs and you'll get all this information again. All right, let's keep going. Okay, so after P1 milestone, you have P1 alpha. This is a longer assignment. You've got 9 days instead of 5. That is related to essentially finishing every task. However, and this is very important, you don't need to be bug-free. You can put a weapon into the game, and it might be buggy and not authentic. It might not feel right, like the original game, but that's totally fine. Because we don't judge you on bugs and bugginess and non-authenticness until your gold submission, which comes up next, okay? On the 15th, the project essentially ends. You submit your P1 gold. This is when you have all your tasks done. They're all pretty much bug-free and very authentic. And you also have a custom level and custom mechanic. These do not have to be big, okay? But it is a little bit of creativity that you do need to put in at the end of this project here. Okay, I want to show you really quick what that looks like. So here is a video, a fantastic P1 Gold custom level and custom mechanic by Nigel Bale and Jennifer Daly. Let's go ahead and look at this video. So you've probably seen The Legend of Zelda before, but you haven't seen that right there. Look closely. That is a motorbike. This motorbike is the new mechanic that the team decided to create for this P1 Gold assignment. And they couldn't just add in a mechanic. They had to create a level that made that mechanic matter, right? You add a new mechanic, and then you explore that mechanic through level design. So this is a really, really cool mechanic where you start the level, you can grab this bike, but then the level, look at this, the level traps you until you try and go to the lava. As soon as you go to the lava, you discover an important part of this mechanic. That is, it lets you jump over gaps, depending on how fast you're going. So we can drive around here. You start going faster the longer you drive. And if you go to the lava, you can do a little hop to get past the barrier. The second room is really great too. It shows you another aspect of the mechanic, that you can use the bike to take down small enemies really quickly by just simply running at them. This next part is a little bit of guidance. The old man tells you not to stop, which means you're going to go through this next room really, really fast. You're going to hold that button down. Oh man, it's a trap, it's a trap. Go, go, go. You go faster and faster. Your speed increases, and then right there, did you see that? Right there, the level design perfectly shows you that you can jump larger gaps depending on your speed. And your speed increases by holding down a direction for a certain amount of time and continuing to drive. So it's just an incredible example of the level design perfectly fitting the mechanic and guiding the player through an exploration of that mechanic. You can use this bike to jump gaps, small gaps. You can use it to run over small enemies. You can use it to escape traps. You can use it to jump large gaps. It's just spectacular. So anyway, that's an example of a fantastic P1 Gold. Okay, I'd like to show you a couple more, but we'll get to that soon. At the very end of your project, from the 15th to the 17th, you'll have a very, very small postmortem to do. A postmortem is essentially a discussion, in this case in the form of an essay, in which you look back at the project in your development period, and you simply reflect to yourself on what went right, what went wrong, what techniques did I use, what didn't work out, what kind of approaches can I use for future projects that are going to help me save time, be more effective, right? Reduce the amount of bugs I generate, stuff like that, okay? It's a very, very short essay, so again, don't worry. And it's extremely satisfying to write. To sit down, to think back at, wow, this project was kind of rough. I wonder what made it rough. You know, I made this poor architectural decision. It didn't scale. You know, the first enemy was easy to make, but the fifth enemy, it was awful, right? But this other part of the project went super well, and I need to continue to refine this technique on P2 and P3. That's the kind of thing you do in a postmortem. Okay. The last thing I want to show you is that while this is a very prescribed project, you do have a list of tasks you need to do. You do have room for creative freedom before you get to P1 Gold, right? A great avenue for that is the old man room. I encourage you to mess around with that message if you want to. And there's some other avenues as well, okay? So hopefully you have a pretty, amidst a little bit of the stress and rush, you have a pretty good time with this project, okay? Okay, does anyone have any questions? I know we moved extremely fast, but again, all this information is available in multiple places, okay? I find it hard to predict how long a task is going to take. It is extremely hard to do this. However, it does get much easier with time as you grow to understand yourself and also just the nature of what kind of systems tend to take a long time to create. So anyway, yeah. you're going to get better. You're going to get better at future predictions. The more you kind of measure how off you are, right? You make a prediction, you actually find out how much time you ended up logging for that task. You discover that you're way more optimistic maybe than you should be. So now all of your future guesses should be multiplied by 2. Okay, awesome. Let's keep going. Okay, so one thing you'll want to do right away with this project is you'll want to set up version control to share a project, a single project between 2 team members. Now, Unity Collaborate is a really, really, really great way to do this. It's something you won't be able to use for Project 3 because there's a max number of team members that Unity Collaborate has. You'll use Git on Project 3. But Unity Collaborate is very, very nice. It plays well with Unity since it's actually built in. And we encourage you to go through this quick setup process described online here. Essentially, at the top of your Unity editor, you'll see a Collaborate button, okay? This Collaborate button will show you everything in your project that you have changed, okay? It's kind of like a change list. And it will also provide you a button that lets you publish those changes to your teammate. If you do that, your teammate can then click a sync button to pull your changes to their version of the game. And so with this, you usually don't have to worry too much about working on the same scene and other gotchas that can happen when using Git. So anyway, it's a very, very cool system. You get to see what you've edited. You get to write commit messages, send them to your teammate. It is a very, very good time. So please consider making use of it for this Project 1. It'll ease your burden quite a bit as you get started. Recommended. You typically want to have the entire team use the same version of Unity. Unity is not necessarily a super stable environment. And so what can happen is if you're on different versions of Unity, you might have strange errors showing up in one person's build, Unity editor, and have those issues not be a problem in another version, in the other person's editor. Another thing that can happen is if you all have the same version of Unity, but it's a buggy one, like it is not an LTS version of Unity, what can happen is one person gets a bug. It's a game-breaking bug, so the only option you have is to upgrade to a new version of Unity. But unfortunately, when you do that, your entire team has to do that. So it becomes like a half-day-long process of getting everyone on the same page. So what I recommend, just have everyone on your team use Unity 2019.4 LTS version, which you'll find in the Installs tab on Unity Hub. It's probably going to be the safest and most consistent and most stable version of Unity to use. Okay. There are 2 more things that I want to show you. One is raycasting. We're going to show you raycasting, what it means to raycast, and why it's an incredible tool for you. And then we're going to take a 5-minute break, and we'll come back with composition. Okay? So let's go ahead and do that. I want to show you a kind of a cool game. If you go to this link right here under raycasting, Stealth Snail. Okay? This is a really quickly made stealth game prototype in which you are a secret snail, an undercover snail, and you need to dodge some guards. If you think about how do you implement guards, typically in a stealth game, they are game objects that have the ability to see in a direction, and if they see the player, they begin to give chase, right? Well, how do you implement vision and sight? There are many ways to do it. But what you'd like to do is you'd like to be able to send a ray or cast a ray out into the environment and discover what it hit. If it hits a wall, it's no big deal. We can't chase a wall. But if one of our rays go out and hit a player, then it tells us that that game object can kind of see the player. Okay? So let me go ahead and show you how this game works, in case you're not playing it. Okay, so we got our snail here. We can see our snail. It's leaving a nice snail trail. Okay, so we're gonna sneak through here. Okay, so here's our first guard. and we can see the guard is looking this direction, okay? If we go around it, there's no problem. The guard can't see us. However, if we go in here, oh, the guard can see us, giving chase, giving chase. If we can escape the guard, it'll stop following us. Okay, so we got far enough away. Okay, and if we come back and cross this line of sight, oh, it starts chasing us again, right? Okay, so I would like to visualize what's happening here. Here is how these guard characters work. Oh, sorry, did I say ray tracing? Yeah, I might have said ray tracing. I meant ray casting. Okay, so I press this button, and now we can see raycast lines, okay? These are the raycasts that each guard is sending out, looking for things. If the raycast goes out and it doesn't hit any other object, then it won't follow anything. It doesn't see anything. However, if it hits a player, the enemy moves into a chase mode. It enables a chase component and will start to follow our player, okay? So that's what happens. Whee! Right? If we were to get behind a wall and break the raycast line, it wouldn't be able to follow us anymore. We'll come over here, we'll drag these characters off the cliff. Ah! Right? Okay. So I would like to show you how this is working under the hood. Whenever you go into a Unity sample project like this, and you want to kind of figure out how things are working, the first thing you always do is you go to the game objects of interest. In this case, you go to an object like player, and you look at its components. Remember, in Unity, nothing happens without a component, okay? And it's the combination of components that make game objects do interesting stuff. So if you look on the right side in here in the inspector, we can see the entire list of the player's components. So we see it has a cube, a mesh filter for a cube, a rigid body. That's not really surprising. That's how we move. It has a sphere collider, and it has one interesting one, arrow key movement, right? And this arrow key movement has a simple API to it. All it wants from you, the designer, is a number that tells us how fast to move. So the player actually is very simple. The player doesn't really have any surprising components or anything. So we probably don't care too much about the player. And certainly the player is not doing any raycasting at all. Let's go ahead and let's find one of the other interesting game objects in our game, the enemy prefab, okay? And there are 3 of these in the environment. If you look, we can see that it has some more interesting components. It has a mesh renderer, we can turn it on and off, sphere collider, rigid body, and it also has a chase transform component and an enemy controller component. Now, this chase transform component does essentially what you'd expect it to. It asks for a target transform, and if you give it that transform, it will follow it. How fast will it follow it? Well, that's the other input we can give it. Velocity, currently 2. We can make these guards much faster by increasing that number. So let's go ahead though. This enemy controller script is very interesting. It doesn't tell us a whole lot about how it works. So we'll go ahead and open this up in Visual Studio. Yeah, if you want to do a cone of vision instead of a line, you can also do multiple raycasts if you want to. Raycasts are a little bit expensive performance-wise, but as long as you're not doing several hundred of them each frame, you'll probably be okay. Okay, so within the enemy controller component, we can see that stuff is already going on. We got some debug visualization happening. And this code isn't all that interesting to us. It's essentially what draws those pink lines that we see when we click that button, okay? However, if we go down to fixed update is a function that works essentially the same way that update does, but it is synchronized with the physics engine instead of the rendering system, okay? So you can think of it as just another update, essentially. Here we find some interesting code, okay? We find a function called physics.raycast. Now, physics.raycast is a really powerful function. It allows us to shoot a ray through 3D space to see if we hit anything. Now, this can be extremely useful, right? For the guards that we see, we shoot a beam from where the guard currently is in the direction the guard is facing for 5 units of distance, okay? And that's how we detect stuff. If we wanted to, so if you think back to your tutorial 1 with the rollerball, question for chat: how many of you had an issue where, hey, the ground, the is on ground variable's working, you hit the ground, you can jump, you're in the air, you can't. But if the player ever touches a wall, like bumps a wall on the side, they regain the ability to jump. So you can jump up the wall like Spider-Man. Did anyone have that issue? It wasn't an issue for grading purposes. We expected you to implement it that way. You used an approach that used on collision enter to check if you touched something, but what you didn't check was whether that thing was beneath you. And using on collision enter, it's really hard to do that. So an alternative you could have done is, you know what? Instead of just touching a piece of ground or a wall, what we're going to do is we're going to raycast beneath us a couple of feet. And if we hit something solid, like the ground, then we know we can jump. If we raycast downward and we hit nothing, then we can't jump, okay? In this case, if the player were to jump against a wall, the system would shoot a raycast downward to see if anything was below us and would hit nothing because the wall's on the side of us, not below us, right? And that would get rid of that issue. If you do a platformer, that's probably the approach you're going to want to take, okay? Yeah, there are some other ways to get around this, that issue as well, but raycasting is one of the more intuitive ones. Okay, so anyway, this function might look a little bit weird to you, right? So this function is being used in an if statement. Well, as it turns out, raycast will return true if it hit something and false if it didn't. So that's kind of intuitive. However, there's this weird raycast hit structure right here. Do you see it? It's a variable that is null. It's not initialized or anything. It has no value to it at all when it's created, and it's fed into the raycast function, right, in this parameter right here, out hit. So what it's doing, essentially, this function is trying to make up for the fact that in C#, unlike in Python, you can't return multiple values from a function, okay? You can only return one bool, right, one value, and raycast is returning a bool. So how do we get additional information about the nature of our raycast? We want to know what we hit, not just the fact that we did hit something. So this is the technique that they use. They have you, the programmer, send in an empty variable. That variable then gets filled with data by the function and then sent back out. That's why this out keyword is here. It tells the compiler that this variable is explicitly meant to be initialized within this function and not before, okay? Then, if you look down here, we can actually query some values from hit. Okay, this variable is filled with stuff that tells us about the nature of our raycast. And so we can get what collider did we hit when we raycasted. Okay, that collider is a component, so it has a game object. That game object has a tag or a name. If it's player, we know we hit the player. So if we hit the player, we should begin chasing a target. What target? We should start hitting whatever we hit with our raycast. Okay? All right, let's go into real quick begin chasing target just to see what happens. This is another cool pattern. Well, actually, I don't like this pattern very much, but I do like this one down here. So when we execute the begin chasing target function, it comes in with a transform, right? This is essentially the game object that the current guard wants to follow, okay? And so, in order to follow something, we need a chase transform component. This is where we put all the logic for following or going to something, navigation, essentially. So we say, hey, if our chase component is currently equal to null, then we need to add one, right? We need to have a chase component or we can't chase anything. So we go ahead and add that transform component to our game object. Once that is established and added to our game object, we can then give it the information it needs. And if you recall, the chase transform component needs to be told what to chase. Okay, the target value is what we fill with a value. Okay, and of course the thing we want to chase is whatever we sent into this function, which in this case is always going to be an object that has the player tag. Okay, and that's essentially how it works, right? Raycasting is pretty darn easy to use, and it can be very, very impactful and effective for a variety of different things. Okay. So does anyone have any questions about raycasting or about this code or about the game that you played? Yeah, so this tag feature, if anyone is confused about the tag feature, any game object can be given a tag. So if you go and say, hey, this block right here is a piece of ground. It's currently on it currently has the untagged tag, but we could give it a respawn tag or a finish tag if this is where the level ends, or a player tag if this is the player. Let's see if the player tag actually has, yes, hold on, there we go. So the player, interesting, oh, the player has the player tag right there, there we go. The guards do not have a guard tag, they're untagged, but if we wanted to give the guards a tag and then use it for some logic, we could go to tag, add tag, and then go enemy. Okay, and we'll go back to our guard here, and we'll give it the enemy tag. However, just because we customize one instance of a prefab, right? We customized one instance of the enemy prefab does not mean the other enemies are going to get that change as well. See, this other enemy is not tagged, okay? If we want to force all of the other enemies to get our change, we can go to apply all, overrides, apply all, and now all the enemies will get that change, okay? So anyway, all right, let's keep going. I think that is just about it. I'll run you really quickly through the released assignments again until we hit 3:30. We'll take our break. So this is what you need to care about today. P1 milestone, it's due Monday. It's very similar to T1 and T2 in that you are provided a template to start this game and a tutorial. You follow the template, you follow the tutorial, and this will take you essentially 50% of the way through your tasks for Monday. Okay? These assignment specs have a ton of information in them and a lot to kind of help you through. So make sure you read them pretty closely. And yes, cool. Another interesting thing to note, if anyone loses their partner during this project, please let us know as soon as possible, okay? So that we can make changes to make the entire project a little bit more fair for you. There are some examples that you can download in this assignment spec. I encourage you to do so. They're not source code, of course, but they are the finished games that will show you roughly what a finished, I think a P1 Gold in this case would look like. You've got P1 Research. P1 Research is an essay assignment, but it also comes with a template. Essentially, you just fill it in, okay? So you don't have to worry about your game structure or anything, your essay structure or anything like that. So we've got tasks here. It's a 4-page paper, but it's 12-point double-spaced, so it's going to go by super fast. I encourage you to split these essays up when you can to make them faster to complete, and you will earn points for getting it done. The template looks sort of like this. You list what genre your game, Zelda or Metroid, belongs to, and then you decide on a game. You say, hey, provide the pitch for your first NES game, provide the pitch for your second, your third game, and then you're going to compare and discuss three mechanical and game design differences between Zelda and your number 1 game, Zelda in your number 2 game, or Zelda in your number 3 game. And if you're Metroid, you'll do Metroid instead of Zelda, of course. Then you're done. The important thing we care about with this assignment is not only that you describe what changes and differences you noticed, but also how do these changes create a different play experience for the user? How is the experience impacted by one design team choosing to have free movement in Star Tropics, and another design team, the Zelda design team, deciding to put the player on a grid, kind of like with Pokemon. What's the difference on game feel? How does this change how interactions and combat work? Okay. So let's keep going. My voice is starting to really go. I apologize. Okay. For project management, blah, 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 blah. We need to get to the spec. Okay, here we go. For project management, this spec has a lot of information, an extensive tutorial teaching you exactly what you should do to get everything set up in Jira. So I would not worry too much. Yep, just follow all of this. You will need to add your teammate to the project before they will see it. Yeah, look forward to that. Cool. Do you have any questions before we take our break? Yes. So remember, a prefab is essentially a blueprint, or you can think of it as a class. And then everything you put into a scene is an instance, okay? A prefab allows you to edit and adjust thousands of instances with one tiny tweak and click of the button, which is why it's so useful to use prefabs, but you need to understand what they do and what they're for. So, okay, let's go ahead and take a 5-minute break. We might end up getting out of class a little bit early. I think we're going faster than the first section. That's fine though. Actually, oh, you know what? I want to show you an example of what some of these P1 Gold projects can look like. So let's go ahead and look at Zelda number 1. Yeah, let's go to Zelda 2. Let's go to let's go to Zelda 1. And I'm not going to show you the custom level here. Okay, so we got Legend of Zelda, right? This looks very authentic. The game plays and feels very similar to the original. You have the classic weapons. You've got the magic sword projectile that flies out when you're at full health. You can walk around on the grid. You're always lined up with either a tile or a half tile. And so you don't have to worry about getting caught on any doors, for instance. We have screen transitions. We have keys in here, bats. The bats behave like they do in the normal game. They have their own resting states where they slow down and then they speed up and fly around randomly. When we get rid of all of these other bats, if I can get rid of them, when you take down all the bats, a key spawns in. What are keys used for? Well, keys can be used to open locked doors. We can see that the classic game has Stalfos. They move and look great. When you hit them, they go knocked back. They've got the right amount of HP. You have to hit them twice. When you get hit, you go bounced back, right? With a really nice aesthetic effect. Yeah. So there we go, right? It's a very, very authentic recreation of the first dungeon from Zelda. And then you've got the classic stage, right? Which we've seen before. Okay, so you've seen that. I would like to show you a Metroid example for the Metroid teams out there. So let's go ahead and hop into it. Okay, so we can adjust our resolution, which is very, very helpful. We can press space for the Nintendo Classic level. Okay. So there's a little bit of a pause here. Okay, so we can run around, we can shoot. We've got zoomer enemies that are authentic. They climb around the outside of surfaces, and we can go ahead and shoot them, boop boop, right? We can jump and run around, and the physics and controls feel about right. There's the morph ball power-up we can grab. And, yeah, the level design is perfect as well. This is one of the really cool parts of Metroid, this room right here. Notice, the game doesn't need to use any text instruction to teach you about how this morph ball works. What the designers decided to do instead was they trapped you in a tiny room that you could not get out of. You can't actually jump high enough to get out of this room. And so the only way to escape is to use the morph ball And the player is very likely to discover how to use it if they ever press down. If they press down, they'll become the ball and they'll see, oh, I can squeeze out. There we go. All right, we've got other enemies in here. We've got, boop, boop, boop. We've got collectibles too, though I don't know if we'll be able to get them. And we can open doors, though that door doesn't look like it's opening, so that's not great, but that's okay. So we can run through. We got different types of jumps. You can jump straight up, and that affects the controls a little bit. If you jump while running, that changes the controls. That's something you'll need to implement, so be sure to study that. And yeah, there we go. If you're wondering about how to study these games and learn more about them, YouTube is a really, really popular method, particularly in these remote times. You watch footage. However, to get feel for the gameplay controls, if you have the funds for it, you can get these games from the eShop. You can find them in a variety of ways. You can get these games for free if you do a little bit of exploration on the internet. Please stay ethical, though, just academic purposes only. Yeah, I'm really looking forward to it. I can't wait to see what you come up with. I cannot wait to see how you what you get done for Monday. We're at our break time, 3:30. So before we move on to talking about composition as a design approach, and explore kind of, okay, why does Unity make such heavy use of components, and how can we benefit from that? Let's go ahead and take our 5-minute break, okay? So I will see you in 5 minutes, and we will turn some music on, okay? See you then, chat. Feel free to ask any questions during this break, and we'll do our best to answer them. Okay, let's do... Do you have any questions, chat? This is DK Country 2. Yep. They can't keyframe a humanoid. It sounds like you've imported human models and have started to play around with the animation system. That's not an error you should be seeing on this first project. So, if it has just shown up out of nowhere, there's a very good chance that one of the models that you imported from the asset store is causing this. So